Welcome to Module 4. This module is all about JavaScript, the language. Now, JavaScript is one of the most used programming languages out there, yet a lot of people don't really appreciate its power. In my personal experience, this is largely due to the lack of understanding of the language fundamentals. I know, I was once in the same boat as well. I admit it. This is why I believe learning its fundamentals is crucial. Another reason why JavaScript doesn't have such a great reputation is historical. In the early days of the web, the browsers implemented JavaScript support much in the same way they implemented HTML support, however they pleased. This caused a lot of heartache for developers because you couldn't be certain that your code would run in the same way in all browsers. In addition, JavaScript used to lack tooling and frameworks that eased difficulties with everyday programming. While things aren't perfect nowadays either, they're much better. There are quite a number of good editors that support JavaScript development and a hefty number of frameworks and libraries that simplify programming JavaScript today. One word of warning. This module assumes that you have the basic understanding of programming. If you don't know general concepts like variables, looping, what an if statement is, and so on, you will have a tough time getting through this module. If you fall into this category, I suggest you find and go through a programming basics tutorial first, then come back and finish this module. See you in the module. Okay, so before we launch into JavaScript and the beginnings of JavaScript, I'd like to rearrange my workspace a little bit to make it a little bit easier on Sublime. Now, why am I doing that? Well, the reason I'm doing this is because when I am going to be editing JavaScript inside some JavaScript file, or for CSS for that matter at this point, Sublime is going to try to help me autocomplete as I type. The problem is that Sublime at this point thinks that all 40 lectures from beginning to end are part of our project, and every single one of them, as you could see, has some CSS in it. Some of them, when we get to Bootstrap, already have some JavaScript in it as well. So all that is going to be tried to be put into the context and put into memory of Sublime to try to help us out. So that's going to create some slowness. So let's go ahead and redo our workspace and only include the lecture, the particular lecture we're on, in our workspace. Okay, so how do we do that? Well, if we go to the command line and let's go ahead and cd into my lecture 40, there is a command that Sublime comes with, and it works on Windows, Linux, or Mac. And this command allows you to start Sublime in a particular directory. So in this case, I mapped it to the keyword Sublime, and if I say dot, which at this point is the current directory, and open it up, Sublime will open the Sublime editor, and it will only have that particular folder as its kind of a workspace. So nothing else will be included. So let's go ahead and do that, and I'll rearrange my windows so we could see a little bit better. Now, how, first of all, did I get to the Sublime, or Subble as it's called actually, this command? Well, if we go to the browser, I opened up a couple of links for you, which I'll include right after this lecture, that will allow you to go step by step, and it will explain to you how to set this up so you can actually do this yourself. Again, it works on Mac, which is very similar to Linux, so you can pretty much follow the same directions except maybe for the folder structure. And on Windows the same way. This is another link for Windows. You could certainly follow this command line tutorial so you can open Sublime for whatever directory you want. Okay, so here I am. I rearranged my windows a little bit. So now I am sitting in lecture 40, index.html, and here's our index.html. So we, just like before, can start browser sync and have the code that we write sync together with the browser, so we won't have to refresh this anymore. So let's go back to our command line, and we are in lecture 40 right here. And as you can see, it's in the examples lecture 40. And let's go ahead and start the browser sync. We'll say browser sync. It's the same command as we did before: start, server, directory, and so on. And we do need star, 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 because if we actually go back, you'll see that we have a JS directory. And if we do an ls in that JS directory, you'll see there's a script.js in there. So if we change something in that script.js, we want that to be reflected in the browser as well. So let's go ahead and start our browser sync together with our star, star, star. So it will go ahead and go down directories as well. We'll start it up, and we'll go to our browser, and you can see here it loaded up the page but didn't execute the index.html yet. So let's go ahead and click on that, and here's our lecture 40 heading 1. Okay, so what we're actually interested in is not so much the page anymore, is we're interested in the JavaScript that is going to run. And Chrome Developer Tools, which is part of Chrome browser, is a great tool to have and to actually use. So what we're going to do is we're going to do Command-Alt-I, and on Windows I believe it will be Control-Alt-I. So we'll go ahead and open Chrome Developer Tools. And this is basically where we've been kind of living for the last so many lectures. We've been living in the Elements tab. What we're going to be living from now on, at least for a little while, is in the Console tab. So when we click the Console tab, this is where the JavaScript and the JavaScript messages are going to show up. Now, we don't really need to see this lecture 40 thing all the time, and I do want this window to have a little bit more space. So the way we could do that is by going this ... and actually undock this whole panel. So we'll do that right now, and that just threw out this panel all the way here. So what we're going to do is we're going to make it a little bit smaller, and we'll align it just like so. And now we can have our full-blown JavaScript console right in front of us as we write our code. So in this here, in the Sublime text, we could try to make this a little bit more minimized, but what we actually should do is just to close it all together because we know where we are. So at this point, we'll go ahead and open up our script.javascript.js and our index.html, and we'll do Command KB or Control KB on Windows, and we'll just close the File Explorer. Okay, so now that we have our development environment the way we want it, in part 2 of this lecture, we're going to speak about where to place JavaScript code. Okay, now that we've set up our development environment the way we want, the first thing we should talk about is where do you include your JavaScript code? Where do you write it? Well, there's essentially a couple of places where you could do that. The first one is you could have a script tag inside the head section. So we could write script, if I could type right now, script, and we could say type equals text JavaScript. Now, the type is technically not required, so if you wanted to, you could basically just avoid it altogether and just have script. And here's our script right now. So this, between the opening script and the closing script tags, you can now write your JavaScript. Another place where you could do that is an external file. So an external file also starts with a script, except it has a source attribute where you could specify an external file. And in this case, it will be script.js because our script is sitting inside JS script.js. Now notice that whenever you include an external JavaScript file, you still have to provide the closing script tag. A script tag is one of those tags that always requires a closing script tag, whether or not there is actually body within the script tag or not. Now, just like CSS and HTML, JavaScript code is executed sequentially. So it means whatever is inside of this script.js file is going to get executed first, and whatever is inside this script tag is going to get executed second. So let's go ahead and try that out. Let's put JavaScript or script.js. Let's declare a variable. We'll talk about declaration variables in a minute, but for now, let's just declare a simple variable. It's going to be a string, and it's going to say hello world. So we'll save that. We'll go to our HTML, and inside the script, we'll go ahead and say console.log. And console.log is something that we're going to be using a lot. And basically, that is a function that's available on every single browser except some really old Internet Explorer browsers, where it will log whatever it is you write in between these parentheses. It will log that to our console right here. So let's go ahead and log our X, since we declared X. And now that I saved the file, our browser sync went ahead and synced the code with the browser, and it immediately said, hello world. Well, where did this X come from? Well, the X came from script. Since inside script I already defined this X, I am certainly very much welcome to use it outside of it, obviously after it has been defined. And the value hello world is obviously coming into this X because it has been defined already inside the script.js. It's also important to remember that the JavaScript engine inside the browser is a single-threaded engine, which means that as the code in your JavaScript executes, it will execute completely without being interrupted by any other JavaScript code from somewhere outside. So it is not a multi-threaded environment, it's a single-threaded environment. And also, as you could see already, it's a sequential execution, which means JavaScript would execute line by line without jumping and inserting other lines of code from other places. Now, the head section is not the only section where I could define JavaScript. I could define JavaScript in a very similar manner that I defined it in the head. I could define that JavaScript in the body as well. So for example, right before body ends, I could say script and close the script tag, and I can have some code right here. So in this case, we'll say console.log, and we'll say right before body closing tag, given an exclamation point. If I save it now, you'll see that hello world gets executed first, since this is what gets triggered first in the sequential execution of the code. And then you see right before body closing tag message, and that gets executed over here at the end, since it's coming after the other JavaScript code. Likewise, I could really take this entire construct, go ahead and cut it, and paste it right here, right at the end, and it will still have exactly the same effect as before, at least in this case. And if I save it, you'll see that I say hello world, because I can include a JavaScript file right in the middle of the body of the HTML page as well. So to summarize, there's a few places where you could actually write your JavaScript code. You could write it inside the head tag, inside the script tag. You could write it outside of the head tag, inside the script tag. Or again, inside or outside of the head tag, you could include a JavaScript file, the effect of which will be as if you're cutting and pasting the contents of that file right into the place where you declare it inside your HTML page. Okay, so in this lecture, we're going to talk about defining variables, functions, and where these artifacts live, otherwise known as scope. Now, it's fairly straightforward how you define a variable. Variable definitions should always start with the keyword var. Now, notice that no types are declared in JavaScript. And the reason that is because JavaScript is called a dynamically typed language. Now, what that means is that the JavaScript engine figures out the type of a particular variable at runtime. And it also means that the same variable can hold different types during the life of the execution of the program. So a variable can start out to be a string, then change to a number, then change to an object, and so on. And all of that is perfectly legal. So that's as far as variable definitions. Now, the way you define a function is by using the keyword function followed by function name and followed by parentheses and then curly braces. Now, in JavaScript, when you define a function name, it's very, very similar to defining a variable whose value is a function. So for example, you could define a function in JavaScript by either using the keyword function followed by the function name, or you could create a variable and set it equal to a function. Now, when you do it the second way, no name is defined after the function keyword. However, either syntax lets you refer to this function as a. Now, notice that the value of the function is assigned to a, not the returned result of the execution of that function. So after either of these definitions, you could now invoke, otherwise known as execute, function by referring to it by its name a. Now, once you define the function, either you define the function the first way that we talked about or the second way where you store the function inside of a variable, the way you invoke a function is by taking the name or the reference to that function and putting the parentheses afterwards. So that is called a function execution or function invocation. Now, the word execute and invoke are synonyms, so you could really use either one. But in programming literature, it's very often that the execution of a function is referred to as invocation of that function. Now, you can also define arguments to be passed to the JavaScript function. Now, the defined arguments are defined without the keyword var. In fact, if you place the keyword var in the function argument definition, that will be a syntax error. If you want your function to return some value, you use the return keyword followed by whatever value it is that you want to return. If the return keyword is not followed by a value, what you're signaling to the JavaScript engine is that it should terminate the function and exit out of it without returning anything. Now, the way you pass the arguments to the JavaScript function is also kind of unique. So in the first line of this example here, we have the function compare that we saw in the previous slide, and it's defined here with arguments x and y. In the second line, we're executing or invoking function compare and passing to it two arguments, 4 and 5. Now, the result of the execution of that function is then stored in the variable a. On the third line, you notice that we're still executing the compare function, but we're not storing the result anywhere. That is perfectly legal. And it's also legal, since JavaScript is a dynamically typed language, to pass a as a second argument as a string as opposed to a number. Now, that may not make sense as far as the logic of the function is concerned, but it's certainly perfectly legal syntax. Now, the last line demonstrates yet another rule about JavaScript functions. All arguments defined in a JavaScript function are optional. You can call that same compare function without any arguments at all, and it will all be perfectly legal. Again, it may not make sense as far as the business logic of the execution of the compare function, but the syntax and the invocation of this function is perfectly legal. Now, each function or variable lives within a particular scope. In JavaScript, there's really two scopes: global scope and function, or otherwise known as lexical scope. Now, lexical here means that it depends on where something is physically defined. Like, for example, a variable that's defined within a function is physically defined within that function. There's no block scope in JavaScript. In other languages, curly braces themselves signify a new scope. In JavaScript, functions signify a new scope. That's all you really need to know about functions for now, and we're going to talk about functions in much more detail in a later lecture. Now, variables and functions defined in a global scope are available everywhere, meaning any other functions that are defined in a global scope and so on can get access to these globally defined functions and variables. As far as function and lexical scope, variables and functions defined here are available only within this function. And you heard it right. You could define functions within other functions. And those newly defined functions have a way to get at its out-of-function variables and functions. Which leads us to the next topic, the scope chain. Now, in order to understand how scope chain works in JavaScript, you have to understand how JavaScript engine executes things. Everything in JavaScript is executed in an execution context. Now, a function invocation creates a new execution context within which that function is executed. Now, each execution context has the following. Number one, it has its own variable environment. This is where it stores its newly defined functions and variables. It also gets this special this object, which we're going to talk about at a later lecture. And what's most important for our discussion right now, it gets a reference to its outer environment, meaning the execution environment within which this particular function is defined. Now, global scope does not have an outer environment simply because it's the most outer there is. So here's how scope chain works. Referenced, notice referenced, not defined variable, will be searched for in its current scope first. If not found, the outer reference will be searched. If not found there, the outer reference's outer reference will be searched, and etc. and so on. Now, this will keep going until the global scope. If not found in global scope, the variable is going to be undefined. Now, we'll discuss the special value undefined when we speak about JavaScript built-in types. But for now, just know that the variable undefined means it's just not found. Now, in order to understand this scope chain a little bit better, let's take a look at the following visualization. Suppose you executed a couple of lines of code inside the global scope. The first line defines variable x and assigns a value of 2 to the variable x. And the second line executes function a. Now, function a itself is defined in global scope, and it has its own variable x that is set to 5. Now, then, within function a, you call function b. Function b is also defined in the global scope, and all it does is just print out to the console the value of x. Now, what will be printed out to the console? Will it be x equals 5 because b is invoked inside function a? Or will it be x equals 2 from the global scope? And the answer is that the result that will be printed will be x equals 2 from the global scope. Now, why is that? Well, if you remember what we just said, the reason is pretty simple. Even though B is called within A, and A has its own X, what actually matters as far as resolving where X is coming from is its outer reference, and B is defined within the global scope. Therefore, the outer reference of function B is the global scope, not function A. What this means is that it does not matter where a particular function is executed. What matters as far as a resolving scope of a variable is concerned is where that function is physically defined. Function B is physically defined inside the global scope. Therefore, a reference of x inside function B is going to look inside function B first. If it doesn't find it, it's going to use its outer reference to look for it there. And its outer reference is the global scope. Let's jump to the code editor and see an example of this. Okay, so here I am in Sublime Text, and I'm looking at script.js, which is located in lecture 41 in the examples folder. Now again, we opened up this workspace exactly the same way we opened it up in lecture 40. So if you don't remember how to do this, please refer to that lecture. We also have our browser sync turned on, and I have my developer tools open that is connected to index.html, which includes script.js. Let's go ahead and close the file explorer so we could see it a little bit better. So the first thing we're doing here is we're defining this variable message in the global scope, and we're just giving it a string called inGlobal. And then what we're going to do is we're going to just console it out. So let's go ahead and save it and see that message pop out. So as expected, we're seeing message equals inGlobal just like we defined it right here. Now, where is this message variable stored? As I told you before, each execution gets its own execution context. So it is inside the global execution context, which also has a special object referred to as this. So let's go ahead and type this and take a look. This actually is referring to window. If you type window here, it's the same object. As you can see, this window object has lots of different name value pairs. And one of them is message in global. So the message variable is actually attached to this variable, which is our global execution context. Let's go ahead and comment some more of the code that we wrote here. And we'll comment the very last line of this function, so we won't execute B. So now we defined a function and stored the function in the variable A. And this function defines its own message variable, that the value of which is inside A. And all it really does is just output the message value to the console. Now we obviously need to also execute this function, so we'll go ahead and uncomment this line. So when we save this, the browser sync should refresh our console, and we should see first global message equals inGlobal, since this is something that is sitting in the global scope. And then when we execute function A, we'll see A message equals inside A, since this message variable is sitting inside of the function scope of the function A. So let's go ahead and save that. This will get refreshed, and just like we thought, we see the global in global, and A is inside A. Now what happens now if we call B from inside A, and B is also going to be defined in the global scope. So here we're not defining our own message, we're just using whatever message comes to us from our outer scope. Well, the outer scope of function B is the global scope. So what we should see is first the message that it's in global, then we'll see A, because A is being invoked right here, and the message defined inside A will be output to the console. And finally, when we invoke B, we'll see this message referring to the global one, since its outer reference is global. Let's go ahead and save that. And as we predicted, message equals from the B function is equal in global. Now let's see what happens if I take this function and I cut it out of here, and I actually define this function inside function A. So let's go ahead and indent this a little bit. So now B is defined inside function A, which means B's outer reference is function A variable scope. So let's go ahead and save that, and now this message B will be the same as message in A. Let's go ahead and save that. As you can see, message in B is inside A, which is exactly the same as message in A. So in summary, we spoke about defining variables. We spoke about the fact that all variables in JavaScript are dynamically typed, which means its type is determined at runtime. Now we also spoke about defining functions and the fact that when you execute a function, it creates its own scope, lexical scope or functional scope. Now it's important to remember that all JavaScript code runs within some execution context, and each execution context has a number of things that are available to it. One of those things is the outer variable environment. And scope chain is used to retrieve variables from outer variable environments that are not found within your own execution context. In this lecture, we're going to talk about JavaScript built-in types. Now, first of all, what is a type? A type is a particular data structure. Now, each language defines some built-in types, and JavaScript is no different. Built-in types can be used to build other data structures that you can then use for your particular business logic. Now, JavaScript has 7 built-in types, 6 primitive and 1 object type. So what is an object in JavaScript? Well, in JavaScript, an object is nothing more than a collection of name-value pairs. You can have one name-value pair, it really can have 0 name-value pairs, but it's a collection of name-value pairs. Let's take a look at a quick example of what that might look like visually. So here I have a person object. It has a bunch of different name-value pairs. First name Yaakov, last name Chaikin, social, and so on. So first name would be the name, and Yaakov would be the value. And so too, a value doesn't necessarily have to be a single value. It could be a nested object. So a name here, for example, is social, the name of the property of the object, and the value of that property is an entire other object that has, again, name-value pairs. So that's object type. What about primitives? Well, primitive type is a type that represents a single immutable value. So what does it mean? A single value means it's not an object. Remember that object is a collection of name-value pairs. Even simplest object there is a name and value pair. Well, the very simplest one has 0 name-value pairs, but the very simplest one that has some data in it is a name-value pair. It's not a single value. Now, what does immutable mean? Well, immutable means once it's set, once that value is set, it cannot be changed. It means that once you set it, the value of that variable becomes read-only. You could certainly create another value based on an existing value, but the memory space that was allocated for the first value is not changed. Instead, you create a new memory space for the new value. So let me run down one by one of all the primitive types that JavaScript defines. First of all, Boolean. Well, Boolean can only have 2 values, either true or false, and true and false are reserved keywords in JavaScript language. Now, if you've ever done any programming at all, and this course assumes that you have, you should be very familiar with this type. Enough said, really. Another type is called undefined. The undefined data type signifies that no value has ever been set on this particular variable of this type. This is the value that every variable gets when the JavaScript engine sets up the variable in memory when it's defined but has never been assigned any value yet. And it can only have one value, and it's a reserved keyword undefined. Now, you can set a variable to the keyword undefined yourself manually, but you should never ever do that. And the reason is because its meaning is that it's never been defined. So defining it and then setting it to undefined is really counter to its core meaning. If you ignore this advice and explicitly in your code set a variable to the value of undefined, that will create tremendous confusion in your code, and confusion in code is never a good thing. Another value that the JavaScript language defines is null. Null signifies the lack of value. Now, the lack of value as opposed to undefined, which signifies the lack of definition. There's only one value you could ever set for that type, and that value is the reserved keyword null. And it's also perfectly normal and perfectly okay to explicitly in your code set a variable to the null value. Another type is number. Well, number is actually the only numeric type in JavaScript. and it's always represented under the hood as a double precision 64-bit floating point. In other words, JavaScript does not have integer type. Integers in JavaScript are just a subset of doubles instead of a separate data type. Another data type is string. And string in JavaScript is very similar to the string type in other languages in that it is a sequence of characters used to represent text. And you could define strings either using single or double quotes. Either one is 100% legal. The last primitive type that I'll mention is symbol. Now, we're not really going to cover this data type in this class. And the reason is that it's new to the ES6, otherwise known as ECMAScript 6. Now, ECMAScript 6 was released in 2015, around mid-2015, and it just isn't widely supported or really used yet. It will probably become quite popular in the next number of years, but it's not there yet, so we're going to skip it for this course. Okay, so time to go to the code editor and see some examples. Okay, so here I am in Sublime Code Editor, and I'm located in the script.js, which is located in the JS folder of the Lecture 42 folder. And again, I opened up Sublime the same way I've been opening it up for the last couple of lectures. Let's go ahead and close the file browser, and let's take a look as to what we have over here. So here we define a variable x, and then we print it out straight to the console. Let's go ahead and do that by saving the file. And as we can see, the value of the variable x is undefined. Well, the reason it's undefined is because it's never been set to anything. So if in the next line I say x equals 5 and save it again, the value will be 5. Okay, so let's go ahead and erase that for a second. And let's uncomment this line of code right here. So this line of code directly tests whether or not x is actually equals to undefined. And if it is, it will go ahead and print out to the console x is undefined. So let's save this and see what our console says. And sure enough, x is undefined. This kind of demonstrates to you that this is a reserved keyword that you can actually test against to see if it's undefined or not. You have to be a little bit careful because JavaScript has this concept of type coercion, which we haven't covered yet. But in general, this is something you could definitely test. Now, let's see what happens if we uncomment this. And what this does is actually sets the value to 5. So now x is explicitly defined. And if we test it against the undefined keyword, it should jump out of the if statement. And we haven't covered if statements, but if statements are pretty generic across many languages. So I'm sure you understand this code here. So if x is equal to undefined, then we'll say x is undefined. Otherwise, else, we'll just say x has been defined. So what is it going to do? It first should tell us x is undefined. And then it should jump and tell us x has been defined. Let's go ahead and save that. So we get our undefined, x is now undefined, and x has been defined. Okay, so all this is well and good. Let's go ahead and comment this out for a minute. And let's do this. Let's comment out the actual definition of x. If we comment out the actual definition of x, and let's try to print out x. And if we go ahead and save that, we're going to get an error. And the error message is a little bit confusing. It says uncaught reference error, x is not defined. Well, what is this a joke? We just said that x is undefined. So is undefined not the same as not defined? And that is correct. Undefined in JavaScript has a specific meaning. And the meaning of it is that it has been declared or defined, so to speak, but it has not been set to any value. So in this case, the variable has been declared and a memory space has been allocated for it, but no value has been placed in that memory space. That's the state that assigns this variable to be a type of undefined. So now if I save that, now it will tell me that the variable is actually undefined. So to summarize, JavaScript defines 7 built-in types, 1 object and 6 primitives. Now, object type is a collection of name-value pairs. It is nothing more than that in JavaScript. A primitive type can only contain a single immutable value, and remember that immutable means that once you set it, it cannot be changed. You could create new values based on this value, but you cannot change the original value anymore. Now, there's a particularly interesting type called undefined among the primitives. And undefined means variable memory has been allocated, but no value has ever been explicitly set yet. And it's important to distinguish between that and variable has never been defined, in which case if you try to use it, you're going to get a reference error and it will be a real error that will pop out in your browser console. So in this lecture, we're going to speak about common language constructs. And these are the things that you pretty much do in any language, but we're going to look at how you get them done in JavaScript. Okay, so here I am in Sublime Editor, and I'm looking at script.js, which is located in the Lecture 43 folder. And again, the setup is very similar. I have the Chrome Developer Tools opened here in the Console tab, and therefore whenever we save this, script.js, the browser sync tool that is running in the background will sense that we've updated this file, and it will go ahead and refresh the browser executing our JavaScript code. So I have a bunch of topics that I'd like to go through, and basically the code for those topics is sitting right in the same file, but I, at this point, commented them out so we could go one by one. The first thing I want to take a look at is string concatenation. Well, just like in a lot of other languages, JavaScript allows you to concatenate strings on the fly as if there are numbers, as if there are arithmetic numbers. So for example, here we've declared a string with the value hello. And in the very next line, we're concatenating the string with another string with a space and the word world. So now this operator right here, plus equals, is really equivalent to the operator. Let me comment that string out. Let me comment that line out. And if I said this, string plus world, this would be an identical line to this one. So let's go ahead and keep both those lines for now, and we'll comment out the second line. And the way I comment out the thing without actually having to type it is to press Control/ on Windows and Command/ on a Mac. And basically what I'm doing is I'm concatenating the string with the word world. And then I'm going to output it to the console using string plus and an exclamation point, another string. So the only difference between these two statements, this one and this one, is that this one is actually going to store a new string in the string variable, as opposed to this one is just going to concatenate it and throw it right into the log function. So let's go ahead and save this. As you can see, it refreshed and it said hello world exclamation point. So let me test this out. As I said before, if I comment this line out and uncomment this one, these lines are exactly equivalent. This is just a shortcut to say the exact same thing as we're saying right here. So let's save that, and again it's going to refresh and saying exactly the same thing. So let's go ahead and comment this whole thing out so we could go to the next example that I want to talk about. So actually let me close the file browser on the side so we could see it a little bit better. Okay, so the next one we're going to talk about is math operators. And the math operators are straightforward, and if you've done any kind of a math operation in other languages, there's really no difference here, pretty much. Actually, let me comment out the second line for now. So the first thing is there's a plus operator, the minus, the multiply operator, and divide operator. And the same type of rules that apply in other languages and really in math in general apply here as well. So for example, the precedence of parentheses also applies here. So as you can see here, I'm doing 5 plus 4, and that will get executed before the division by 3. So 5 plus 4, that's 9 divided by 3, that's 3. So if I save that, I should see that it is going to output console.log output 3. Now let me uncomment the second line here, and what we're doing here is kind of strange. We're doing undefined divided by 5. Now when we execute that, let's go ahead and save that, we're going to get an NaN. Now what is NaN? NaN is a special symbol that indicates not a number. And the biggest reason I'm showing you is because it's very common to define a function. Let's say we define a function test1 that takes an a argument, and in the function we'll do console.log, and console.log will say a divided by 5. So now if we call this test1 function, we never really passing the a in here. So what's going to happen? Let's go ahead and save that. You'll see we're going to get an NaN again, not a number. So when you debug your code and you call a function and somewhere inside the function something starts throwing not a number, chances are that there's something that was supposed to be passed into that function and either got neglected to be passed in, or something happened to it along the way right before it was supposed to be passed in, and then you have an undefined variable inside your function. Okay, so let's go ahead and comment this out. And we'll save that again, so we'll clear the screen for us. And let's go to this topic called equality. Let's uncomment this. So here what we have is we're declaring a variable, defining a variable x equal to 4, and defining a variable y equal to 4 as well. Now notice, by the way, that we're defining them with only one keyword var. This is a shortcut in JavaScript that if you wanted to, you could just put a comma in between variable definitions, and that is perfectly legal syntax. And in fact, this is very common in other languages as well. In the next line, we have an if statement, and the if statement in JavaScript is nothing special compared to any other language. It's pretty straightforward. And what we're doing here is we're comparing x and y, and we're comparing it with a double equals operator. Now, one of the most common mistakes is instead of double equals is to say x equals to y. Well, x equals to y will take the value of y, place it in x, and use the result of that as the value to evaluate whether or not it's true or not. So we don't want that. We actually want to compare x and y, and therefore it's a double equals. So what we're doing here is saying if x is equal to y, then we're going to execute the next line, which is this console x is equal to y. Let's go ahead and comment the second part out here and save that. And you can see it says x is equal to y because x is 4 and y is 4 as well. Now let's make this a little bit more interesting. Let's uncomment this line and see what we're doing here. Here, first of all, we're changing the type of x. The x now is no longer 4 as a number, x is 4 as a string. So what happens if we actually compare them now? Well, let's go ahead and try that. Let's save that. And you can see it says x equals to 4, 4 is a string, is equal to y equals to 4. Now, what is going on here? Obviously, the string can't possibly be equal to a number. Well, what's going on here is called type coercion. And type coercion just means that the language converts something for you from one type to another type automatically on the fly. So when the JavaScript tries to evaluate this equality, it converts one of the types to be the same type as the other variable and only then compares the values. Now, what if you didn't want that? What if you didn't want JavaScript to automatically convert things for you when trying to evaluate its equality? Well, that's where strict equality comes in. Let's go ahead and comment that out and go to the strict equality section here, and we'll uncomment that. So strict equality is signified by using triple equals. So now if I'm comparing x triple equals to y, it will first see whether or not these things are this x and y are the same type. And if they're not, it's not going to try to compare them anymore at that point. And in fact, I just realized I commented out x and y that I'm defining here. So let's go ahead and actually uncomment this whole thing. That way we'll have the variables available. So now if we execute this, x at this point is a string 4 and y is a number 4. So this will never actually execute right here. What will execute, however, is the else part. And here you get the chance to see what else looks like in JavaScript. And it's really, again, nothing special. Other languages have basically the same construct. And in the else clause, we are having console.log that says the strict x as a string 4 is not equal to y equals 4. And that is what we actually should see in the second printout. So let's go ahead and save that and see what it says. It says strict x is not equal to y equals 4 because 1 is a string and 1 is a number. In part 2 of this lecture, we're going to pick up where we left off and speak about what JavaScript considers false and what it considers true. In part 1 of this lecture, we left off speaking about strict equality versus regular equality. In this lecture, we're going to go ahead and pick up speaking about what JavaScript considers Boolean true and what JavaScript considers Boolean false. So like all languages, JavaScript has a specific set of things that it considers to be false or true when you evaluate Boolean expressions. So let me go ahead and comment out this whole section, and let's go to the next section where it's talking about the if statement, but we're actually going to list everything that the if statement would consider true and everything that the if statement would consider false, or actually the other way around. False first. Okay, so in this if statement, I listed every single thing that the if statement will consider false. The first of all is it's going to consider the keyword false as false. Now then you see something that is an OR operator. Now the way the OR operator works is that if something evaluates to true on its left side, it does not check anymore what is going to be to its right side. And since I know that to its left side at the moment is going to be false, I can be sure that it's going to evaluate this, and if this is false, which it is, it's going to try to evaluate this for truthfulness. And if this is true, it will stop and will not evaluate anymore. However, null also gets coerced to being false in JavaScript. So therefore, we keep continuing to say null, which is again false, or undefined. Undefined is a keyword that also gets coerced to false in JavaScript. Next, it's an empty string, so it's basically double quotes with nothing in the middle. That also gets coerced to being false. 0 gets coerced to being false, and NaN, not a number, gets coerced to being false. So the point is that every one of those things is false. That means this line will actually never execute. And in fact, it's going to go to the else clause and execute all is false. So let's go ahead and save that, and you can see it says all false. Now let me show you a very quick trick that if you ever forget if you have something and you're not sure, is it supposed to evaluate to false or true? Well, JavaScript provides these wrapper objects around the primitives. So even though Boolean is a primitive type, there's a wrapper object called Boolean with a capital B that you can actually pass things to see what it would coerce to. So for example, if I pass it a null, that will coerce to false. And there you go, it tells you false. If I pass it something like an empty string, it will coerce it to false. But if I pass it anything else that is not in the list of false things that we listed right here in that if statement, so if I pass it something like hello world, that will evaluate to true, which brings us to the next thing of what is true in JavaScript. Let's go ahead and uncomment this if statement. And here, what is true in JavaScript? Well, first of all, the true keyword is evaluated as true in JavaScript. After the keyword true, you see two ampersands. And two ampersands signify the logical AND operator. And the way the logical AND operator works, it will only return true if both things on the left and on its right are true. So if both of these things are true, this will be true. And again, so since we have a non-empty string here, this will evaluate to true. Then we ending it again with a number 1, which is a number, not a 0. Anything not a 0 also evaluates to true. And just in case you think a -1 would evaluate to false, it does not. It actually also evaluates to true. Any number that is non-zero will evaluate to true. And if we end it with the string false, even though the string itself has the value false, but since it's a non-empty string, that will evaluate to true. So if we save this, we'll see the statement all true. Go ahead and save that. The first one is all false from this clause, and the second one says all true. Okay, so we're going to stop here for part 2 of this lecture, and in part 3 of the lecture, we're going to pick up speaking about whether or not putting curly braces in the same line or next line is a matter of style of JavaScript or really an established best practice. Okay, so enough of Boolean expressions. Let's go ahead and comment that out. And let's go to the next topic, which is best practice for the curly braces. Curly braces on the same line or on the next. Whenever you speak to people about their preference, whether or not the curly braces, either for a function of some other construct, should be on the same line as some wording or keywording, or should it be on the next line, sometimes you get into a pretty big religious war whether or not you should have it one way or the other. Well, that religious war doesn't have to be in JavaScript, because in JavaScript there's actually an established best practice, and that best practice is not just a matter of style, it's a matter of syntax and how JavaScript engine works. So let me demonstrate that for you real quick. Let me uncomment this. And what we have here is we have two functions. One is function A, another one function B, and we're going to execute function A and then execute function B, logging the output of each function. So function A follows a style is where it's always putting the curly braces on the new line. So function A starts and the curly braces on a new line, and it returns an object. Actually, this is an object literal. And don't worry about that. We're going to talk about objects a little bit later, but the point is this is something that needs to be here, which is a curly brace. So it's returning the object literal, and it's also putting the curly brace on a new line. Function B does exactly the same thing, except it follows the style that puts the opening curly brace on the same line as the function declaration and on the same line as the return statement. Now let's go ahead and execute function A and then execute function B and see what it gives us. Let's go ahead and save that. Did you expect that to happen? The first value from function A is undefined. Now, why is that undefined? Well, this actually brings up another interesting issue that is going on in JavaScript. The reason it's undefined is because what the JavaScript engine does behind the scenes when you execute this code is it looks at the return statement, doesn't see anything after it, and places for you a semicolon right after it. So basically what this function A is doing is starting to execute and immediately returning, and it's returning nothing. And since it's returning nothing, when we try to output nothing, it gives us undefined. As a side point, even though semicolons at the end of statements are optional in JavaScript, it is pretty much an accepted best practice to always put them there. Now, there's some minor, I would say very minor controversy about that, and there are people out there that insist that they want to have it without the semicolons at the end. However, by and large, people put semicolons and are very strict about it, so you should probably follow the best practice of the majority. So now you understand why in this case it returned undefined, and in this case it's actually returning the object with a name value pair, name being the name property and value being Yaakov. Okay, so let's go ahead and comment this out and go to our last topic for this lecture, which is the for loop. What language can there be without a for loop? Let's go ahead and comment that out. And here's a for loop. Well, this for loop is doing something very simple. It's defining a sum variable to be 0 to begin with, and then it's looping from 0 to 9 and summing up everything in between. And then it's outputting what the sum from 0 to 9 is. So let's go over this for loop real quick. So just like many languages, the for loop has three parts to it. First is the initialization part of initialization of the counter variable or other conditions. The second one is the condition that the engine will check to see whether or not the loop should be run again. And the third one, some sort of either increment or decrementer or something like that. So the first thing is we're declaring a variable I equal to 0. That is going to be our starting point. By the way, if this variable I has been declared in this scope already once, declaring it again with a var would be a syntax error. So if I have a for loop a little bit above it that also has var I equals 0, this for loop would just start with I equals 0. I don't have a for loop above, so I will go ahead and declare the variable I equals 0. Jumping to the last part, we see I++. Well, this is another one of those shorthand notations for I equals to I plus 1. It's the increment operator. In order to make this a little bit shorter to type, I++ will do. There's a very similar operator, by the way, that is I minus minus that subtracts 1 from whatever variable it's applied to. In this case, we want to increment it by 1, so it's I++. So we're starting with 0. In the very first time, I is being compared to 10, and 0 is less than 10, and I is being incremented by 1. Then the body of the loop executes, and after that, when we hit the curly brace, it comes right back, increments I by 1, and then checks it again. Is I, in this case, 1 less than 10? We'll go again and again and again until I reaches 9, in which case it will go ahead and execute the loop one more time, increment I to become 10, and 10 is not less than 10, and it will go ahead and exit the loop and output this line for us. So let's actually go ahead and put a console.log in here, and we'll output I as the loop keeps going. So let's go ahead and save that and take a look at the result. So as you can see, it's going all the way from 0 to 9, and the sum of 0 through 9 is 45. So we went over quite a bit in this lecture, so let's quickly summarize. We went over the string concatenation, and we went over math operations and how the typical precedent rules applies there just like it would apply in pretty much all the other languages. And if you want to know more about it, there's certainly much more to learn about it. You could go to the Mozilla Developer Network and delve deeper into that documentation. We spoke about type coercion, that is dynamically converting a type to a different type for either addition or comparison or a different type of other operations that you would need both sides of the operand to have the same type for. We also spoke about the regular and strict equality, the regular equality being with double equals and the strict equality being with triple equals. And the big difference between them is that the strict equality will first compare to see whether or not both sides are the same type. And if they're not, it will not consider them equal. It will not check anything more. So type coercion will happen with double equals, the regular equality, but strict equality prevents type coercion. We also spoke about what is true and what is false in JavaScript, what is considered true and what is considered false in JavaScript. We also talked about opening curly brace placement. It's not just a style in JavaScript. In JavaScript, it's very important that you adopt the style of putting the opening curly brace on the same line as the function definition or a object definition and so on. Now, as a general good practice, always place semicolons at the end of every statement. Now, there are some that disagree, and I provided a link here for you here to an article that makes a really good case as to why you might not want to do that, or at least might not have to do it, absolutely have to do it. Kind of makes fun of the people who insist on it. But the bottom line is most people do that and place the semicolon at the end of pretty much every statement. So you should probably adapt it no matter what anyway. And last but not least, we spoke about the basic for loop syntax, and I showed you some simple code to sum up numbers between 0 and 9. Okay, so let's talk about a very common scenario that happens a lot when you're coding. And before we begin, I am located now in lecture 44 in the script.js. So I have a function here, and the function is order chicken with, and it lets you pass a side dish, and really it's very simple, just prints back out to the console the order chicken with and whatever the side dish is. So in this case, we're calling it order chicken with, and we're passing a string noodles. What it should print out is chicken with noodles to the console. So if we save this, and indeed chicken with noodles gets printed out. Now, what happens if I call the same function, but I pass nothing to it? Well, side dish will become undefined in this function. So when the side dish is undefined, it should print chicken with, and it will coerce this side dish variable into string undefined. So if I save that, I'll get chicken with noodles, that's the first call, and the second one, chicken with undefined. Well, obviously this is not something we want the user to see, or really is not very helpful. So what can we do to avoid that? Well, we could create a default value that if the value for side dish is not provided, we could substitute it with that value. So let's go ahead and do that. The simplest way of doing that is just to create an if statement. So we'll say if side dish is equal, and we can even do triple equal, to undefined, and we'll go ahead and say that our side dish is equals to the string noodles. There we go, it's already sitting there. Okay, so now when I save this, the second time it calls, it will say noodles. In fact, actually, let's change that to, let's say, side dish with whatever. Okay, so now when I call it without any arguments, it will see that the side dish is undefined, and it will print out chicken with whatever. Let's go ahead and save that. And there it goes, that's chicken with whatever. Now this is all nice and well, but the thing is this is a little bit too verbose, and JavaScript has a shortcut way of doing the same thing. And let me go ahead and code that for you now. So what you could do instead is you could say side dish is equal to side dish or whatever. The string whatever. Now, so how is that working? First of all, let's see if it's working, right? So let's save that. And it still says chicken with whatever. So how is this working? Well, the reason this is working is because each and one of these values is getting coerced into a Boolean value. And we spoke about coercion before. So when we make the second call without any arguments, the side dish here, this variable, is undefined. So undefined right here gets coerced into a Boolean and becomes false. So if it's false, or the second statement will get evaluated. And the second statement, since it is a non-empty string, gets evaluated to true. And what the OR statement does in this circumstance is actually returns the value before it was coerced. So what it actually returns to side dish here is the string whatever exclamation point. Well, let's go check that out in the console. So we have this wrapper class called Boolean, and we could say, okay, what happens if you do true? In fact, forget that. We'll just do true or false. If we do true or false, it will say true. What happens if we do empty string or true? You will say true. But what happens if we say hello or empty string? it will say hello. So it will return whatever coerces to true first. So here we never even got to evaluate the empty string. So if we reverse that, we'll still get hello. We'll still get hello, this hello. And the reason this never got evaluated is since this evaluated itself to true, the OR statement no longer has to evaluate anything else, because the OR statement by its definition says if the first thing it sees is true, it is no reason to evaluate anything else, because it's an OR, right? It's either this is true or this is true. Well, once you know this one is true, then it no longer matters what anything else is coming behind it. So this is one way to set up a very quick default value type of scenario. And if you open up professional code of jQuery library or any professional libraries out there, or really any professional JavaScript code, you will see this construct quite a bit. So I wanted to make sure to cover it here, so if you ever see this code kind of in action, you won't be confused as to what it's trying to accomplish. In the lecture on JavaScript types, we mentioned one very special type, that is object type. An object is, again, a collection of name-value pairs. In this lecture, we're going to go over how to create objects in different ways and how to assign properties, in other words, how to create those name-value pairs. Okay, so currently I am in the Sublime text and I'm looking at script.js and I'm located in the lecture 45 folder. Let me go ahead and close the file explorer. And what you see in front of you is a very simple object creation. So we're creating a company variable and we're setting it to new object. Once we've created a reference to an object, we're ready to create properties of that object. Now in JavaScript, when a property doesn't exist and you simply mention that property in an object, JavaScript engine creates that property for you. So for example, we could say company.name, and that property name doesn't exist yet, but the second I set it to something, or the second I mention it on the object, it becomes a reality, and now it does exist. So now if I go ahead and do console.log, and I output the company object, I'll see, let me save that, and you'll see that now the company object has a name property, and the name property value is Facebook. But let me erase that, and I can keep going and say company.ceo, and I want CEO to have several properties, and I want CEO to be an object by itself. So let me just go ahead and try this. First name is equal to Mark, and let's go and save that, and maybe we'll do console.log, and we'll output company again. And let's see what happens. And when we save it, we're going to get an error. What is the error? The error is cannot set property first name of undefined. Now, what is going on here? Why is this not working? The reason this is not working is because company.ceo is something that hasn't been defined yet. Remember, just like if I said var a and then try to do a dot hello equals, I don't know, hello. Let me comment this line out. So if I save that, it will give me the hello of undefined cannot set property hello of undefined. So it's the same type of issue. So what do I have to do here? Let me uncomment this line. What I really have to do here is I could specify dot first name, but I first have to create the dot CEO property. So let me go ahead and copy it here and say here new object. Once I set CEO to the new object, now I could set the property first name on it. Let me go ahead and save that. And now I can see that object has first name and has CEO, which is also an object. So if I open that up, and I see CEO is an object, and CEO has a first name, Mark. Well, let me set another property. Let's give Mark his favorite color, the CEO fave color. I'll give it blue since Facebook is blue, and we'll print it out again to the screen. So now we have CEO fave color and first name. And just like I set the properties with a dot notation, I could certainly get at the property with a dot notation. So for example, let me do another console.log, and I could say that, let's say company CEO name is, and put a space, and I'll do string concatenation. I'll say company.ceo.first name. Okay, and we'll put a semicolon at the end, and we're kind of going off the border here, so maybe we'll just, JavaScript is very liberal with spaces, so we'll just do that. And when we save it, we could see that now it says company CEO name is Mark. So the JavaScript engine traversed the object's company and went to the CEO property, which is also an object, and then went and retrieved the first name property. Now, the dot notation is not the only way for me to get at the properties. I can also do the following. I could say console, let's go ahead and do console.log, and what we'll do this time is we're going to use the bracket notation. So we'll say company, and we'll say bracket name, and name will be in quotation marks because now we're getting at the property name, and the name is a string. And go ahead and output that. So you see now it's getting to be Facebook. So I can get at the company name using the bracket notation, not just the dot notation. Now, why is there two notations here? Why can't I just use the dot notation? Well, the reason I can't always use the dot notation is because the dot notation will only work with whatever is a valid JavaScript identifier or valid JavaScript either function name or valid JavaScript variable name. So for example, if I wanted to say that company dot $stock, and remember $sign is something JavaScript variables, identifiers, and function names are allowed to start with, and I'll say stock is equal to 110, let's say that's how much it is, and I'll go ahead and do console.log and console.log company, and we'll output that. You could see that the stock property got set to 110. But what if I wanted to be kind of, very dramatic? I don't want to just say stock. I want to say stock of company and put spaces in here. Well, I can't really do that, and I can't really do that either. That wouldn't work either. However, what would work is instead of the dot notation, I'll put it in the brackets notation. And when I do that and save it, you'll see that our property is now named stock with a $sign of company. And I could probably remove the $sign now. That was only for the effect of the variable name. So now if we look, we have stock of company, and that is the name of our property. So I can now go and retrieve the stock price by saying, okay, stock price is, and we'll concatenate the string and say company, and since I can't really do a dot stock price because it's stock of company, what I could do is I could use the bracket notation the same way and say stock of company. And if I save that, I'll see stock price is 110. And notice that it doesn't have to be a string literal here. I can actually set it to a variable. So if I go ahead and cut that out of here and say var stock prop name, and I will set it to stock of company, and I'll go ahead and use stock prop name right here, and we'll do the same thing over here. Let's do stock prop name. And if I save that, everything works exactly the same way. So I'm able to actually calculate the name of the property in my code on the fly. Okay, so let me fix this up so you can see it a little bit better. So if I save it again, everything works as expected. Now this is a way to create an object, and it looks kind of verbose. There's new objects everywhere. I wish there would be kind of a shorter way to create the same thing that would be much more readable. And in part 2 of this lecture, we're going to take a look at a syntax that does just that. Okay, so I'm located still in script.js, which is located in lecture 45 folder. And in part 1 of this lecture, we spoke about how to create a simple object and how to set properties on it, and we even talked about how to set an object within an object, and so on. Now in part 2, we'd like to take a look at a syntax that simplifies all this object creation. What we'll do for now is we'll go ahead and comment all of this out, and we'll create a new one. And we'll create the object in a bit of a better way, or at least simpler way. So let's go ahead and make a comment here, better way, object literal. And what we're going to do now is called object literal notation. Let's go ahead and set our object to a little bit of a more interesting name. Let's call it Facebook. And we'll give it an object literal. An object literal is just curly braces. And we could put a semicolon at the end because it's a statement, or actually it's an expression that's going to have its value sitting inside the Facebook variable. And since JavaScript is very liberal with spaces, we can actually make it much more readable by putting space right here and starting to type properties just like this. Name Facebook, name of the company is Facebook, and we're separating our name value pairs the name value pair itself is separated with a colon, and the actual name value pair is separated with a comma. So we put a comma in, and we'll put CEO. That's what we wanted to have as a sub object within this object. And since it's a sub object, we again put curly braces, and we open it up this way. Let's erase that extra line. Okay, so first name was Mark, and we separate this with a comma. Fave color was blue. Notice the last name value pair inside the object curly braces does not get a comma at the end. That's very important. Now this right here, from this curly brace to this curly brace, is an object literal by itself. And this CEO together with curly brace object is a name value pair. So since we want yet another name value pair to appear afterwards, we want to put a comma after here and then say something like stock, and the stock is going to be equal to 110. So if we save that, this is going to get cleared, and we're going to do console. Let's actually make some room here. Do console.log and output Facebook. So let's see what it comes out to be. And it looks exactly like the object we created before. And we have the CEO sub-object sitting here with a favorite color, Mark. And don't worry about this proto property for now, but CEO is an object, has a favorite color, first name, and we still have the name of the outer object be Facebook, and the stock price is 110. We can also repeat this the same thing as we did before here, where we wanted the stock name to be a little bit of more of an elaborate type of name. So we want it to be stock of company, right? So let's go ahead and copy that name. And we could do the same thing here by specifying the property name to be a string. So we could just say quotes, don't forget the colon, and paste the name of the property right here. So when we save and it refreshes, now we have the value or the name of the property be stock of company with the spaces, which is something you wouldn't be able to set using the dot notation, but you're able to set using the object literal notation, and certainly are able to set using the bracket notation. And we could access the properties of this object exactly in the same way as we accessed it before. So there is really no difference between the way to create the object this way and the way we created it with a new object. So we could still say Facebook.ceo.name, and when we save that, we'll see that I messed up something here, right, because we had not dot name but that first name. Let's go ahead and do that and save that, and you can see it still outputs Mark. So everything works, and this is exactly, again, the same way to create the object, and this is a much better way because it's much more readable and much faster to type. I'll add two more words about how to type up these objects. Now, a lot of people make a mistake is when they say var, let's say company, and they say equal, and they do this, and they start expanding this thing before, let's say CEO, and again, like this. It's much easier to first put all the ending things on the line. So for example, the way I type things is when I say a company and it's equals to curly braces, and I know that it's going to be an object, and I know that this is an expression, and I want to put a semicolon at the end, I put a semicolon at the end right away. So that way, when I put my cursor in between the curly braces and just put a space, now the syntax doesn't look as bad because it's much easier for me to type. So when I say CEO, again, and I put two curly braces right here, and I know there's going to be a second property after this, I will put a comma right here and then say stock of company, something like this, and say 110. So that way, when I get to here and I put a new line here, I'm not really worried anymore to try to remember what is this curly brace closing. Do I need a comma here? Maybe there's another sub-object in here. So it's much easier to put all the ending characters to your programming line up front instead of wait till the end and try to match them up later. So that's just a little quick tip for you to know going forward. Okay, so we have our two ways of create the objects. One way is using the new object syntax, and the other one is what's called object literal. Okay, so now that we spoke about objects, it's time to speak about what functions really are underneath in JavaScript. I'm located in script.js, and that is sitting inside the lecture 46 folder. Let me close the file browser here, and let's take a look at a very simple function. Here, a function multiply, and it takes two arguments, x and y, and it returns just the multiplication of x and y. So the first thing I want you to know is that functions in JavaScript are what's called first-class data types. What that means is that whatever you could do with a variable, whatever you could do with an object, you could also do with a function. You could pass it around, assign it to a variable, which is you've seen before. You could pass it as an argument to another function. You could return it as a return result from a function. Functions in JavaScript are objects. They are regular objects that have some special properties to them. So since they're regular objects, I should be able to set properties on them just like I set properties on any other object. So for example, here's I have a function called multiply, and let's test that it works. Let's do multiply, let's say 5 to 3, multiply 5 by 3. And if we save that, we'll see that, well, I forgot to console it out. Let's console.log multiply 5 by 3. And we should see 15, and we do. Okay, so now what I could do is I could set a property on the multiply function just like I set on any other object. So let's go ahead and set a property called multiply dot, let's say version, and let's set it to version v1.0.0. Okay, and let's go ahead and console.log, and let's console.log the actual function multiply. So we're not actually calling the function. If we call the function, we would have to put the parentheses after it. But we actually just want to output the value of the function. Let's go ahead and output the value of the function. Let's save that. And we forgot to put console.log. No problem. We'll fix that. And the value of function is the function code itself. So the reason that's happening is because every object has this inherent method or inherent function to it that's called toString. So if we do toString and call toString on it, we're going to save that and get exactly the same thing. So what we want to do is actually get that property version. So if we do multiply that version and now we save that, you'll see that the version is been set on our function. So our function is nothing more than an object. Now, the fact that it's an object allows us to do quite a number of interesting things that are so useful in every application. Let's go ahead and actually erase a couple of these code statements, so we'll just have the multiply version. And what we'll do is we'll start making function factories. Okay, so let's call this function factory. So what we're going to do is we're going to create a function, and the function is going to be called make multiplier, and we're going to provide a multiplier for it. So what we're going to do is we're going to return a multiplier function out of this function. So we're going to say var myfunc equals, and we're going to make it equal to a function. So we'll do function, and the function is going to take an x as an argument. And again, as I told you, I will put the semicolon right here so I don't get confused later. And what I want to return is multiplier. Where's my multiplier? Multiplier. I meant to say multiplier. So I'm going to return multiplier times x. And that's what I'm going to return out of this function. There you go. Okay, so now what I need to do is I need to now return this function as the return result of the function make multiplier. So what I need to do is say return myfunc, and now the value of this function, that is sitting right here is going to be returned as a return result. And that allows me to do quite fun things here. Let's try to make a multiplier by 3. So we'll say multiply by 3, and we're going to create a function that does that for us. Make multiplier, and our multiplier is 3. So now what multiply by 3 is a reference to a function that we made inside this function. So in order to invoke it, we'll do console.log so we could see it. And we'll do multiply by 3. And we'll put, let's say, 10. So multiply by 3 times, so it's 10 times 3. So it should return 30 to us. Let's go ahead and save that. And sure enough, it returns 30. So we can make another one. Let's say we'll make another one called double all. So everything is going to get doubled. So we're going to say make multiplier again. And it's times 2. So now console.log, let's say multiply or double all, and we'll pass it, let's say 100. So this should return 200, and we save it. And sure enough, it returns 200. So you see what we're doing here. We're creating a function. We created a function double all, and the way we created it is by passing a multiplier into our make multiplier function. Our make multiplier function then creates a function for us inside of itself and then returns it as a value. So since again functions are just objects, we should be able to pass them around just like we pass around any other arguments to functions. So let's call this one passing functions as arguments. So let's go ahead and create a function called do operation on, and we'll give it an x. That's the value we want the operation to be done on. And the second parameter we'll call operation. So in this case, let's go ahead and create the curly braces here. In this case, what we want to do is we want to actually execute whatever function you pass to us on the value x. So what we need to do is return, and it's operation, and we need the parentheses in order to invoke the function, and it's invoked on x. Okay, so let's save that. And now we could say result, var result, and we could do operation on, and we could create a value or pick a value. Let's say 5, and we'll say we want multiply by 3. Now notice we're not passing multiply by 3 with parens. That would actually execute the function multiply by 3. We just want to pass a reference to that function multiply by 3. So when we do that, we get a result, and the result will be multiply by 3 passed in with a 5, so it's 5 times 3. So let's go ahead and console it out. We should get 15. So our result is, let's go ahead and save that, and we do get 15. And we can do the same thing again. Result equals, we don't need to declare it anymore because we already said var. So it's do operation on, and let's say 100, and then we'll do double all. So we are multiplying now, we're having a double all as a reference to our function double all that we created right here, and we're passing it into our do operation on as a reference to that function. And once we get it as a reference, we can go ahead and put parens around it and pass it the x that we're passing through the do operation on, and that will execute that function, return the result, and store it inside the result variable. So let's go ahead and console it out again. So let's make some space here so you could see .log, and we'll do result, and then this time it should give us 200, and sure it does. Okay, so in this lecture you can clearly see that functions are first-class data types. You could pass them around. They're nothing more than special type of objects. You could pass them around and treat them as objects, pass them as arguments, return them as the result of a function execution, and even set properties on them just like on regular objects. This is actually one of the core features that makes JavaScript so powerful and so flexible at the very same time. There's a concept that's very important to understand for really all languages, and certainly JavaScript is no different. And the concept is passing variables by value versus by reference. And this is what we're going to discuss right now. Now, first of all, what does that mean to pass or copy things by value, variables by value? So the loose definition is that given b equals a, so if you have an a and a b, and you're copying the contents of a into the variable b. So passing, when it's talking about functions, or copying in case of just regular equality, b equals a. So copying or passing things by value means that changing the copied value in b does not affect the value stored in A, and vice versa. So if I change B after I've copied the value of A into B, A stays the way it was before and B changes but does not affect A. On the flip side, passing or copying things by reference means that given B equals A, again we're copying the contents of A into B, passing and copying by reference would mean that changing copied value in B does indeed affect the value stored in A and vice versa. So they're kind of pointing to the same location. Now in JavaScript, the way it works is that primitives are passed by value and objects are passed by reference. Or to say it another way, primitives are copied by value and objects are copied by reference. Now, the truth is that underneath the hood in the JavaScript engine, everything is actually passed and copied by value. And the difference is why one is really called pass by reference and one pass by value really comes because of the way the objects and primitives are stored in memory. So let's go ahead and take a look. So here on the left we have primitives, a is equal 7, and then we're copying variable a, or the contents of variable a, into variable b. And on the right, we have a variable a that is equal an object that has a property x to be equal 7. And then in the second line, we're copying the contents of a into b. So b in the end of the day, in both circumstances, ends up with the same value as a, at least at this point. So the question is, how does that work? Let's take a look at some visualization to understand this. So when it comes to primitives, the first thing that happens is we declare variable a and we equal it to 7. So what happens in memory is that a gets memory allocation. In this case, the memory address is 001, and the value that's sitting in that memory is 7. Now, when we declare variable b and then copy the contents of variable a into b, what we're doing is we're allocating another memory location, in this case 002, and we're copying the value 7 into that memory location. So then when we overwrite the variable b with the value 5, what we're actually doing is we're placing a different value into the same memory location that b is pointing to, in this case 002. So in this scenario, what you end up with is that A is still pointing to its original memory location 001, which still has number 7 in it as the value in that memory location, and B is now pointing to 002 with a different value. So therefore, A and B really have nothing to do with each other. They really just a copy, or originally were copied one into the other, but at this point, they are not affecting one the other. And this scenario is what is referred to as passed by value or copied by value. So let's take a look at the same scenario, but in case of objects. The first thing that happens, of course, is again we declare an object. In this case, we declare an object literal with the property x7. So what's going on is that A gets again allocated a memory location. Again, in this case, 001 is the address in memory. And what gets put into that memory location as the value is another memory address. So inside the address 001, the value in that position in memory is another memory position that is pointing to another part of memory. And in the address 003 is where the value actually sits. Now, the truth of the matter is I'm actually oversimplifying this. What is actually sitting in the memory location 003 is a list of other memory locations where they have the same type of relationship where it's a primitive now and it's pointing to a particular memory location at which memory location value 7 is stored. But to make this a little bit simpler and not to confuse you further, I'll just say that memory location 003 is where the actual value is contained, or the actual value is stored. So then when we declare variable b and we equate variable b to a, what's actually happening is that, again, the value of variable a, where variable a is pointing to, is copied into variable b. Well, the value is 003. It's a memory location. And it's copied into b, so b now, even though it's sitting at a memory location 004, its value is another memory location with a value of 003. So what ends up happening is they're both pointing to a memory location 003. So finally, when we update b.x equals 5, what we're actually updating is the memory location where b is pointing to, and that is the memory location 003. The value, the direct value of b, still stays the same. It's the value that it's pointing to that is changing. And since both A and B are pointing to the same value, the end result is that both are pointing to a changed value. And this is what's called pass by reference. So the bottom line is the difference between pass by value and pass by reference is that in pass by value, the values, once it's changed, do not affect their original value or the original variable. As opposed to pass by reference, when you change the value and the object that's passed by reference, the original object that's pointing to it is changed as well. So that's the theory behind how pass by reference and pass by value works. In part 2 of this lecture, we're going to jump into the code editor and we're going to see these concepts in action. In part 1 of our lecture, we spoke about the theory and kind of tried to understand what does it mean to pass something or copy something by reference versus by value. In this lecture, we're going to look at some examples so we can experience these concepts in code. So I'm currently looking at lecture 47 at the script.js file that is located in the lecture 47 folder. I'm going to go ahead and close the file explorer here in Sublime, and let's take a look at our example code. So here we have a variable a equals 7, and then what we're doing is we're copying a into b, and 7 obviously is a number, so it's a primitive, so it should copy into variable b by value, which means b is no longer pointing anywhere to where a is pointing to. So if we console them out, console.log them out, and let's go ahead and do that right now, I'll just comment this out for now, you'll see that both are 7. Now what happens when we change b equals 5? Well, since b is pointing to its own memory location, b is not going to affect where a is pointing to, so they're both going to go on their merry way. In other words, after b's update, a is still going to remain to be 7, and b now is going to be 5. Let's go ahead and save that and take a look. So sure enough, a is now 7, and b is 5. So that's passed by value. Let's go ahead and comment that out. And let's take a look at a different example. Let's save that. Take a look at a different example, which is passed by reference. And now we're speaking about objects. Let's uncomment that. So in the first line here, we're having a equal to an object literal that has a property 7. And then we're copying a into b. So as you remember from the first part, what we're actually doing is copying the memory location that it's pointing to this object literal into b, not the actual values. So if we now output a and b, let's go ahead and do that, you'll see they're both objects that have x property equal to 7. So now if we go ahead and update b, in other words, b.x equals 5, what we're actually updating is we're updating this object which both variables are pointing to. So after update b.x update, if we log a and log b again, you'll see that both a and b have changed the x value to be 5. So let's go ahead and save that. And you can see here after update, x is now 5 from logging a, and x is still 5 from logging b. And again, that is simply because they're both pointing to the same memory location. So these two examples are examples of copying by value and copying by reference. But we've been using a different term called passing by value and passing by reference. And that term really only applies when we speak about passing value into function calls. So let's go ahead and take a look at one of those examples. So let's uncomment that. So here we have a function called change primitive, and we're going to pass a primitive value into it. We're going to go ahead and tell our console that we're inside the change primitive, and we'll log the value before we change it. Then we're going to change the value and log the value after we change it. And afterwards, we're going to go ahead and invoke that. So we'll say the value equals 7. We'll pass it inside that change value function. And notice that when we pass a value inside the change primitive function, what is really going on is that the value 7 is being copied and equal to prim value. It's really no different when we're passing it here than saying, and I'll put it in the comments, but in memory what's really going on is that prim value is being equal to value. That's really what's going on. So it's really a different form of copy that we saw before. So actually, let's leave that alone, so it will be a comment here. So, and afterwards, we're going to go and announce that we're done with the change primitive, and we're going to log our original value. And the original value should stay 7, even though we changed it inside the change primitive function, simply because they're pointing to prim value, and value are still pointing to different memory locations. So let's go ahead and save that. And it will execute. So we're in change primitive before it's 7, because we passed 7, so it got copied into this variable prim value. And after, right here, it's 5, because we changed that. And after change primitive has been called, the original value of the value variable is still 7. And it's because they're pointing to two different locations just like before. It's really just a copy of the value itself. It's not pointing to the same memory location. So let's go ahead and comment this out so it doesn't crowd our console, and save that, and should clear it. And let's go to the last example here, and let's uncomment it. And we're doing exactly the same thing, except now we're changing object. And since objects are passed by reference, what we should end up with is we should end up with the same object that's pointing to the same location. So the setup is very similar. We have a value that is an object literal with a property x equal to 7. And again, when we're passing it into the change object function, what we're really doing is we're saying obj value is equal to value. And this is the same thing that's going on in the previous example, except that now we're calling it passing, right? Because we're actually passing this value into the function change object. Inside the function, we're again announcing that we're inside the change object function, kind of console out the object value that is passed into us, changing the x value of it, logging it afterwards, logging the entire object again just to see what it is after we change the x. And then when we come back from the function, we want to know what the original value is. Has it really changed because we changed it inside the function? And obviously it should change because both the obj value and the value variables are both pointing to the same memory location. So let's go ahead and save it. As you can see, before object is x7, after object is x5, and after we call change object, the original value now is changed and it's x5 because both of those variables were pointing to the same memory locations, so they are affecting the same values. So this is how passing by value and passing by reference works in code. So to summarize, it's very important to understand this concept, that is passing by value versus passing by reference. You can't really code without understanding this basic concept. And the simple rule to remember is this: primitives are passed or copied by value, and objects are passed or copied by reference. And again, copying or passing by value means that the new variable really has no relation to the old variable, and changing the value in it will not affect the old variable. As opposed to passing or copying by reference, changing that new variable, changing the values in that new variable will affect the values of the old variable from which the object was actually copied. In this lecture, I'd like to show you one more way to create objects in JavaScript. And it's a very common way, especially if you have functionality together with those objects, very similar to like a Java class, for example. Right now, I am in script.js, and I am located in the lecture 48 folder. Let me go ahead and close the file explorer. Before we jump into yet another way how to create objects in JavaScript, I'd like to explore one particular topic. Let's go ahead and write a function, and we'll call this function, let's say, test. And all we'll do this function is do console.log, and we'll say hello Coursera. Okay, so if we save that now, well, nothing's going to happen. We actually have to call that function. So let's go ahead and call the function test. And now we see hello Coursera. Now, we discussed in one of the previous lectures as to what happens when you actually invoke a function. We discussed the fact that a new execution context is created within which this line or whatever is inside the function is actually executed. And we also discussed the fact that that execution context gets a special variable called this. Let's find out what this variable is pointing to. Let's do a console.log. Truth is, we could just delete this and just put it right here. And let's log what this is at this point, this special variable. Let's go ahead and save that. And this is pointing to the global window object, right? That's the object that has all of these parameters, all of these properties. And in fact, if I actually set a property on this object, say this dot my name, give it Yaakov. So if I save that, and if I output this again, and in fact I could do it right here, I could say this or window dot my name, and I could log that out, console.log. And it will say Yakov, because what I did here is, since this is pointing to the global object, window.myname, or my name property, was created on the window object. Okay, so that's all nice and well, but if we actually wanted to kind of encapsulate some data within a particular object and use a function for it, then we would need this to point to something else. And this is where function constructors come in. Let's go ahead and erase that and create yet another function. Let's just say function constructors. Okay, so let's create another function, and let's call this function circle. We're going to create circles, and this time we're going to say circle with capital C. Now, there's really nothing about capital C that does anything special other than it lets me know that it's a function constructor. So it's basically just a convention to let other developers know that this is a function constructor as opposed to a regular function. And a circle should have a radius. And what I'm going to do inside the body of the circle is actually nothing more than just say console.log, and I'll go ahead and log this. And here comes yet another way that we're about to learn as to how to create objects. Let's go ahead and create a variable called myCircle. And what I'm going to do is, instead of just invoking the function circle, I'm going to use the new keyword and then say circle and give it, let's say, 10 as the radius. When I invoke a function together with the new keyword, the JavaScript engine makes this point to the object itself that got created, which is the circle. So if I go ahead and console.log the actual myCircle, and so now I'm going to console.log this, and I'm also going to console.log myCircle. It really should be the same thing. Let's go ahead and do that. And then both are empty objects that are of type circle, or sort of type circle. It's not a real type, but it's an object with a name circle. So this means that technically what I could do here is I could say this dot radius, so I could create a sort of a member variable or a property of this circle object, and I could say radius. So now the radius that I'm creating the circle with is going to be stored as part of my object. So if I go ahead and log the circle now, you'll see that now I'm a circle that has a radius property of 10. Now what's really going on behind the scenes here is that this line right here is really pretty much equivalent to saying new object, as we've done before. And then that object gets named after the function that created it. So it's really a function constructor in that it creates a new object by executing this function in a special way using this special new keyword. Now the function constructor itself, or the function circle, cannot return anything. So if the function returns, let's say, an empty object, an empty literal, and I'll save that, you'll see that we're not really getting the behavior that we want. myCircle is now just an empty object. So we can't return anything from the function constructor. It has to remain without a return value. And the new keyword will arrange for us that when it creates an empty object and then sets it to be a circle, it will go ahead and return that object and store it in whatever variable that we're providing for it. So let's save it again. Now we see our circle with the radius 10. Now, what would be an object without some methods? And methods in JavaScript are just functions that are set on properties of objects. So let's go ahead and create one. Let's go ahead and create a this.getArea, and this.getArea is going to be nothing more than a function. And let's go ahead and put this function on a separate line. And the function is going to have no arguments because we're actually going to get at the radius using the this keyword. So we're going to go ahead and have curly braces. Won't forget to say a semicolon here because this is just an expression that gets set to the getArea variable. And here we can use a JavaScript predefined object that actually has been pretty much created the same way that we're creating our circle. So we'll say math.py times, and there's another math method that's called POW, power of our this.radius. And we wanted to raise it to the power of 2. And we'll go ahead and put a semicolon after that. Okay, so now we have a getArea method or getArea function that will calculate the area of the circle. So here we created a circle with a radius 10, and we're outputting the circle. Let's go ahead and output myCircle.getArea. And we need to put parentheses after it because this is the function and we're invoking it. So now that we save it, we could see that the area is been calculated. So 10 to the second power, so 100 times pi sounds about right. Let's go ahead and take a little bit of a closer look to this myCircle object that gets created. Let's go ahead and log it one more time. And you see my circle object has a radius of 10. And if we open it up, we'll see the radius is 10 and has another property called getArea. And the value of getArea is a function. The problem is, as we keep creating these circle objects over and over in our code, we're going to keep creating this getArea function over and over in our code, because every time we say new, this entire thing gets created. While for radius, it's perfectly normal because each circle should have its own radius, we really don't need for a type circle to have its own getArea on every object it creates. It really should be just created once, and all the circles, all the instances of a circle, should share it. And the way we could do that is by using a special property called prototype. So let's go ahead and cut this out of here. And we'll say circle.prototype getArea, and that is what is going to be equal to our function. And the function is going to be anonymous since we already have the name getArea right here. And again, we don't need an argument because we're going to use this keyword. And the body, we're going to say math.py times math power of this.radius to the second power. So that is actually what we need to return. Okay, so there's our getArea. So let's go ahead and, before we even call getArea ourselves, let's go ahead and take a look at myCircle object one more time. Let's go ahead and save this and output in myCircle object, and we'll take a look, and you can see that the radius is here. The radius equals 10, but getArea doesn't exist here. Well, where is it? Well, it's actually sitting inside of the special variable underscore underscore proto underscore underscore. That's a special property. If we open that up, you'll see that getArea now is right here. And proto is something is going to be existent on every single instance of this object. So if we, for example, create another one, var my other circle, and we'll say new circle, and we'll give it 20 as the radius, and we'll go ahead and console.log my other circle, you'll see that the radius here is 10, and there's no getArea, and the radius here is 20, and again, both of them are pointing to the same proto variable that have a getArea, and this getArea is actually the same location in memory as this getArea. It's the same thing, so it doesn't get recreated over and over. Now, a couple of words of caution. Number one is circle.prototype.getArea is not something you should cut and put inside this function. You could certainly do that, but that would be a mistake. And the reason that would be a mistake is because this function is going to get executed every single time you create a new circle. Well, every single time you don't need to define a prototype. In other words, what you'll be doing is you'll be overriding the memory space of getArea every single time you create a new circle. So basically that's wasted processing. It's not really wasted memory space since it's going to put in the same memory space this function over and over again, but it's wasted processing. So you really should not be putting that inside of a function constructor. So definitely put this outside. Let's go ahead and indent it this way. So that's caution number one. Caution number two is make sure you don't forget the new keyword, because if you omit the new keyword, let's go ahead and comment this out. Let's go ahead and log this variable. You'll see it's undefined. Well, the reason it's undefined is because this is nothing more than a function. It's just a regular JavaScript function. So a regular JavaScript function that you're passing 10 to and actually does not return anything. Well, when it doesn't return anything, this myCircle becomes undefined. And if you actually try to say that getArea, right, we're going to get an error because it says cannot read property getArea of undefined, because myCircle at this point is undefined. So make sure you remember to put the new keyword there. One clue is to always make the function constructor names capitalized. That's why you'll remember that this is not just a regular function, it's actually a function constructor, and you must use it with the keyword new. Okay, so let's uncomment this back out and save it, and now everything works as we expected. So these are function constructors. You could create an object using them using the keyword new, and you could set a prototype property on that function such that whatever property you just set on it will only be created once and will not be created for every single instance of that object. In a previous lecture, we saw how the this keyword behaves itself when it's part of a function constructor. That is, it's referring to the function itself or the object itself when that function is invoked together with the new keyword. In this lecture, I would like to look at object literal and how the this keyword behaves itself inside of one. So I'm looking at script.js and I'm located in the lecture 49 folder. So let me go ahead and close the browser and let's create an object literal. Let's call it literal circle since we've done circles before. And an object literal is just two curly braces, and don't forget the semicolon at the end. And we'll give it a radius of 10. Okay, so an object literal with a radius of 10, and we'll put a comma and we'll give it a get area, and get area is going to be a function. Its value of this property is going to be a function. We don't need the name, we already have get area, and we're not going to give it the argument either. What we're going to do is we're going to do console.log, and we'll console.log this right inside the get area method. So let's go ahead and save that. And once we created that object literal, let's go ahead and call the get area function and see what happens when we do console.log this. We obviously have not really yet, at least, calculated the area. So let's go ahead and save that. And we'll see that what's going on here is that this is no longer referring to the window object, to the global object, but it's actually referring to our circle class, or to our literal circle, which is an object with a radius of 10. And if we open it up, we'll see that it has a getArea property and a radius of 10. So when an object literal gets created, this, instead of pointing to the global object, is actually pointing to the actual object that got created. Therefore, what we could do is we can do return math.py times math.power, and we could say this dot radius to the second power. So this is referring to the literal circle object, and it has a property called radius, which is right here. So therefore, this is perfectly legal and it should work just fine. So let's go ahead and actually console.log the answer to our getArea execution. And when we execute that, we do get 314 and so on. So this actually worked just fine. Now, why is that? Why is it that this is working? Why is this keyword referring to the object instead of referring to, like any other regular function, to the global object like a window? Well, believe it or not, you already know the reason to this. And the reason you know this is because when we discussed object literals, I told you that this statement right here, when you open the curly braces, is really tantamount to what? New object. So when that happens, this is actually what's executed in the background, new object. Well, you see that new keyword again. And when we see the new keyword, this variable inside of that object is now referring to the actual object and not to the outside window or outside global object. So this in fact works exactly like function constructors in terms of the new keyword, right? Even though the new keyword here is kind of implicit, well, everything's here implicit since this is an object literal. Now there is a bug, or at least what most people consider is a bug within the JavaScript implementation. In every single browser, it's really within the JavaScript specification. And the bug comes out in this fashion. If inside getArea, I will go ahead and create another function, just like I can, and I'll say var increase radius. And it's going to be a function, and I don't need a name again, and I don't really need an argument here either. And inside the body of the function, I am going to go ahead and increase the radius to 20. So I'll say this dot radius equals 20. So now when this method executes right here, or this line executes right here, this dot radius should now be 20. So it shouldn't be 314. It should be a much larger area of the circle. So let's go ahead and actually invoke, we just defined this function here. Don't forget the semicolons because that's an expression. Let's go ahead and invoke this function right here. So now after this invocation, this dot radius should be 20, and this whole line should execute with the value of this dot radius equals 20. So let's go ahead and save that. And what do you know? It's still 314. That's kind of strange. Well, let's go ahead and console.log what our radius is. This dot radius. What exactly is our radius before we execute this, but after we increased the radius. Let's go ahead and Save that, and it's still 10. Now, where did this 20 go? Well, the way this works is that when you have an inner function within another function, this keyword starts pointing to the global object. And we can actually test this by saying window.radius, and this should say 20, and so it does. So this 20 actually got set on the global object instead of on our literal circle object. So how do you get around this? Well, there's a common pattern that people use to get around this. And the way you get around this is you just say var self equals this. So now that you have self, self is always going to be referring to this, and this, at this point at least, is referring to the literal circle object. So instead of in the inner functions referring to this, you always refer to self. So now radius is equal 20, and now this should update the radius inside the object literal, inside our literal circle. So when we execute this line right here, this dot radius should be equal to 20, not 10. Let's go ahead and execute this. And as you can see, now our radius is indeed 20, and the area is much larger. So this is the way you get around this kind of an annoying JavaScript bug, and I guess there is a disagreement out there whether or not that this is a bug or this is intended and this is how it's supposed to work. Either way, it's not really very useful, and in fact, in the new JavaScript version, which is ECMAScript 6, this supposedly has been fixed. In this lecture, we're going to speak about arrays in JavaScript. I'm assuming you already know what arrays are, but if you don't, arrays are just a collection of data. In JavaScript, however, since we have dynamic typing, arrays take on a pretty interesting set of properties. So right now I'm in Sublime Text and I'm looking at script.js, and I'm located in the lecture 50 folder. Okay, so let me close the browser and let's create an array. So let's call it var array, and we'll say new array. Once I created the array, I could now set items into that array. And arrays are zero based. So I could say 0, and let's say in the first position, which is position 0, I'll place a string and I'll use my name, Yaakov. In the second position, which is position 1, I'll place a number, let's say 2. In the third position, which is 2, I'll place a function, and let's say it's going to be a function that you could pass a name to, and let's put a semicolon there, and all of this function is going to do is just going to say hello and whatever the name is plus name. Okay, so in the third position, which is right here, or the fourth position I should say, I'm going to place an object literal. We'll put a semicolon over there. And the object literal will say course, that's the property name, and the name of the course is HTML, CSS, and JavaScript. Okay, so here's my array. And if I do a console.log on the array itself, you'll see that we have the array. And as you can see inside the array, we have different types of objects stored there. Some are just primitives, and some are strings, some are functions, which are also objects, and some are just object. So because of dynamic typing, in JavaScript, I'm able to store different types of objects in the same array, which is not true of most languages. Most languages, when you have an array and you store data in an array, the data in one particular array has to be of the same type. And if you want to have more than one type, you have to separate it into separate arrays. And just like I set the values using this brackets operator, I can also retrieve the values using the brackets operator. So for example, I could say console.log, and I can output array sub1, or sub1 right here. So array sub1, meaning I want to go to the second item in the array, which is right here, and I want to output it to the screen using a console.log. So if I save that, and you see it prints out 2. Furthermore, since at position 3, or really at index 2 here, we have a function, I can invoke this function very easily using the array notation. So I'll say array, and it's at position 2. So I'll say position 2. And now since at position 2 is the value, what's sitting in here in this position 2 is the value of the function. So that's the function value, not the return of the function, but just the function value, which means in order to invoke it, all I have to do is put parentheses after it. And once I do, I can save it and undefined. And the reason it says hello undefined is because I never passed name. So let's go ahead and say Yaakov and save that. Now it says hello Yaakov. But I can even do something more fun than that. I can actually pass in the array because I already have Yaakov stored right here. So I could say I'm passing in an array and it's in position 0. So now what I'm doing is I'm retrieving position 0 of this array, which is Yaakov's string, and I'm passing it to position 2 value, which is the value of the function. So the function is getting executed against the value Yaakov. So if I save that, I'll get again the same thing, hello Yaakov. Likewise, I could certainly retrieve a property of a literal object that is stored inside the array. So I could say here console.log, and I could say array sub3 or index 3, and I could say dot course, and that should print out HTML, CSS, and JavaScript. Let's go ahead and save that, and it says HTML, CSS, and JavaScript. Okay, I can also create arrays using a shorthand array notation. So let me go ahead and comment this out so it doesn't crowd our console. So we'll save it and we'll clear the console. Let's go ahead and say shorthand array creation. Okay, so what we're going to do is say var names, and we're going to create an array simply by providing an empty brackets. So empty brackets now creates an array in the variable names. And what I could do is I could start listing my names. Yaakov, John, Joe, let's see. Okay, so if I do console.log now, on the names, I should say that, or see that array right there, Yaakov, John, and Joe. So that works, great. So now you see there's two ways to create an array. One is kind of a longhand notation where you say new array, and the other one simply by kind of like an array literal, something like that. But so you just use the brackets and you separate the array values by a comma. And again, I could put whatever I want in here. So if I wanted to, let's say, I can actually use spacing here like this. And if I wanted to, I could create an object here. So let's say I could create an object and say name Yaakov and comma, there's another object here. If I wanted to have an object, we'll do name John. And I can actually leave it here because arrays are not restricted to have the same type. So if I save that, and I'll see object Joe, right? So if I actually open that up, I'll let me open this object and you'll see array Yaakov, name Yaakov, and the same one is, second one is name John. Okay, but let's undo that for now. Let's go back to the regular array we had before. And let's go ahead and loop over this array, printing out each name. Let's say hello to each name. So for that, we're going to use a regular for loop. We'll say var I equals 0. And we need to keep looping until it's the end of the array. Well, there's 3 items in the array. And each array object has a special property called length. And it's not a function, it's just a property that the JavaScript engine sets for you. So array names.length will give me the length of the array. In this case, it'll be 3. So what I'm saying is that I want my loop variable to be 0, 1, and 2, and when it's 3, it's no longer going to be less than the length of the array, and it will quit. Okay, so let's go ahead and print hello to the console. So we'll say console.log, and we'll say hello, space, and then we'll say names, bracket I. So now every time through the loop, the I is going to change, and it's going to say hello to a different name. Let's go ahead and maybe comment that out so we don't see that on the console. And we save it, and we say hello Yaakov, hello John, hello Joe. Now what's interesting about arrays in JavaScript is that they can even be sparse. So let's go ahead and make some room here. And I could say something like names, and I could say names 100, and I could set that value to be, let's say, Jim. So now we have an array that has 0, 1, and 2 index and an 100 index, and in between there's nothing there. So if I actually go ahead and take that here and paste that loop right here and execute it, what we're going to see is it said hello Yaakov, hello John, hello Joe, and it starts that again, hello Yaakov, hello Joe, and then 97 times it just says hello undefined. Because what we're doing here is we're saying I want you to retrieve names with an index of 4 and 5 and 6 and so on. And those indices just don't exist in this particular array. But 100 does exist, so therefore you see when it gets to 100, it prints out hello Jim. There is one more issue with arrays that you should be aware of, and we'll discuss that issue in part 2 of this lecture. There is one more issue that you should really be aware of when it comes to using a certain for loop with arrays. Let's go ahead and comment all this out, and I'll go ahead and copy my array one more time, and I'll just call it something else. I'll call it names2 maybe. Let's see, names2. So I have a names2 array, and again it says Yaakov, John, and Joe. Okay, so let's leave that aside for now, and let's create an object literal. We'll create obj, let's say my obj, and we'll create it as an object literal. We'll put the semicolon there, and we'll say name Yaakov. We'll say another property, course, HTML, CSS, JavaScript, comma, and we'll say platform, Coursera. Okay, so that's good enough. So now there's something we actually haven't seen yet and I haven't shown you. And there's a special for loop that you can use to traverse the properties of an object. So this for loop looks like this. It's a for, and you declare it as a var, prop in my obj. So basically it'll say, I want to grab every property in my object. This is what this prop is going to be. So it's very convenient for objects because objects don't really have indices like an array does. It has properties. So let's go ahead and console that out. Console.log prop, and we'll say semicolon here. We'll add that in, and we'll add my obj, and we'll give it prop again. And since dot notation and the brackets notation are equivalent, I'm allowed to do this. So this lets us kind of calculate it in the calculated property. Okay, so if I save that, and I'll see that it's printing out name, that's the name of the property, and the value, name of the property, and the value, name property, and the value. Okay, that's all great. Now we know that in JavaScript, arrays are just objects, and the indices are just property names. So technically speaking, I could use the same type of for loop on my names2 array as well. So let's go ahead and try that. Let's actually comment this out for a minute so we don't have it crowd our console. Let's make a little bit more room. Okay, so now let's say for name in names. So sounds pretty good. So we'll say console.log and we'll say hi, hello, and we'll say names, and we'll use a computed property notation, name. So every time through the loop, this name will be equal a different property of the array. So in the first time, it will be equal 0 because that's a property name of the array. The second time will be equal 1, and the third time it'll be equal 2. So this should work. Let's go ahead and save that. And I messed up something here. Names is not defined. Of course not. Names2. Let's go ahead and say names2 here. Let's save that again. Names2 is still not defined. And that's because I didn't put names2 right here. Okay, so now it will work. So now it says hello Yaakov, hello John, and hello Joe. But the problem with this for loop is that arrays are objects after all. So if, for example, there's nothing wrong with me saying names2.greeting is equal to hi. Let's say I want to save a specific greeting that I want to use. So now if I use the same array, I'll go ahead and copy that and say afterwards, hi. And now that if I use the same array, and let's go ahead and comment that out for a minute and save it, what I'm going to get is hello Yaakov, hello John, hello Joe, hello hi. Now the reason that is because the greeting became a property of the array, no different than a number 0 or number 2 or number 1 and so on. Greeting becomes a property of the array. And this for loop loops over the property names of the object. And since again, arrays are just objects in JavaScript, this for loop will loop over properties, even over properties that really have nothing to do with the core data that we want to loop over. In this lecture, we're going to talk about JavaScript closures. Now, closures is a pretty essential topic to understand. In fact, without this concept implemented in JavaScript, something like Ajax wouldn't really even be possible. And believe it or not, closures is something you've already seen. So right now I'm looking at my Sublime text at script.js, and I'm located in lecture 51 folder. So let me close the file browser. And let me give you an example that you've seen before. Let me create a function, and the function will call make multiplier, and we'll pass it an argument called multiplier. And in this body of this function, we're going to return, and what we're going to do is we're going to return a function. So we're going to say return, let's put parentheses around it so we could see it a little bit better with a semicolon at the end. And what we're going to do is we're going to return a function without a name. We don't need a name for it because it's just a value of the function. And the function that we're returning should be able to take one argument, let's call it x, and what we're going to do is we're going to return multiplier times x. So this function, make multiplier, is going to take a multiplier that is supplied to it, some number, and is going to return another function as part of its return value that is going to take an argument, a number, and is going to multiply it using the multiplier provided in the outer function. So let's go ahead and execute this function. So let's say var double all. We're going to double everything, and double all is going to be equal to make multiplier 2. So double all is now a function that doubles everything. So let's go ahead and say console.log double all, and let's say 10. And when we save that, and when I save that, it will go ahead and take 10, multiply that by 2, and we should see 20 over here. So let's save it, and 20 is what we see. Okay, great. Now let's for a second understand how did this work out. The very first time we called make multiplier, we passed it a value of 2. So now when we get to this portion right here, it's really no different than saying var multiplier right there equals to 2. That's really what's going on. So according to our rules, I should be able to use this multiplier inside of an inner function. So before I even get to the return, let's go ahead and create another function. Let's call it function, I don't know, let's call it function B, and we'll just say console.log multiplier is, and we'll output the multiplier. And let's invoke the function right there. Now when we invoke the function, let's go ahead and do that. Save it. We invoke the function and it says multiplier is 2. Now how does the inner function right here B know that the multiplier is 2? Well, we spoke about what happens when a function is executed. When a function is executed, it gets a few things. Number one, it gets its own execution context, so it's isolated from everything else. Number two, it gets a special this variable. We spoke about that before. And number three, it gets a reference to its outer lexical environment. So when a variable is referenced inside of a function, the first thing it does is check whether or not this variable has been defined inside of its local lexical environment, meaning has the multiply variable been defined inside the B function? And the answer is it's not defined. And if it's not defined, that means the next thing that the JavaScript engine does, it looks at the outside lexical environment of this function. Well, the outside lexical environment of this function, meaning where it's defined, the outside of that is the make multiplier function. And the make multiplier function has that variable, so once it finds it, it goes ahead and uses it in the function B that we're executing right here. Now that's all great. Now let's take a look at our return statement. The problem is that our return statement doesn't really create its own execution environment, because this is not a function execution. This is just a function value. This is an object, a function that gets returned back to the caller of the make multiplier function. Okay, so if this is not an execution of the function, that means it doesn't get its own this variable. It means it does not get an outer reference. It simply gets returned to the caller. So now, when it gets returned to the caller in this line right here, so this variable is now equal to this function. And in the next line, when we actually execute double all and pass it a 10, This function is now finally being executed, which means it is now getting its own execution environment, and it is now in this line right here, it gets its own execution environment, and it gets its own outer variable environment, and so on. So how then can it possibly know what the multiplier variable is? Because at the time that this is executing, the make multiplier function is no longer in the execution stack. It's done. It returned whatever it needed to return, and it's no longer functioning. It's done. It's popped off the execution stack. Well, the reason this still works is because of JavaScript closures. Since a function like this is returned from inside of this function, JavaScript preserves its outer lexical environment memory space for this function, so this function can go ahead and produce what it needs to produce. So the multiplier is something that's still sitting in memory in lexical outside scope of this function. So even when we call double all, it will go ahead and execute this function. It will create its own execution environment. It will go ahead and look for the multiplier variable in its own execution environment. It will not find it, and it will then try to look for this variable in its outer lexical environment. And the outer lexical environment memory space will still remain even though the make multiplier function no longer exists. That's how we basically are able to trap or to close in whatever variables and whatever memory space is sitting outside of the lexical environment of this return function. And that's how closures work. In this lecture, we're going to speak about a pretty common scenario and how to resolve it, and we'll look at some best practices as well. Right now, I'm in Sublime Text, and I'm located in the Lecture 52 folder. Let me go ahead and close the file browser here so you can see a little bit better. And I'm looking at index.html at the moment. What I'm doing here is I'm actually loading 3 scripts, one after the other. Script1.js, script2.js, and app.js. So this happens a lot when you actually import a couple of libraries, and so those libraries could be something you wrote yourself, or it could be external libraries as well. But in this case, these are 2 libraries that I wrote myself, and they're very, very simple. The first one is just declares a variable name. It's my name, Yaakov. And then the function say hello. And the function say hello does nothing more than just says logs hello plus the name, and it'll just say hello, Yaakov. Script number 2, which is what is declared afterwards, script number 2 is declaring a name John, and then it declares a function called say hi, and all it does again is just logs hi plus the name John. Now app.js, this is the third one in the list over here, app.js, it invokes say hello. This is from the first one, says hello, so it should say hello Yaakov, and then it invokes say hi, which is right here, and it should say hi John. Let's go ahead and save this and see what the console prints out. We save it and it says hello John and then hello hi John. Now that's kind of strange. Hello John, it really should have said hello Yaakov, not hello John. Now why is this happening? Well, it's actually pretty simple why this is happening. If you look at our index.html, the first thing that the browser loads is script1.js. And script1.js declares a variable name, and this name variable is sitting in the global scope, and it also declares a function called say hello, again in the global scope. So when this executes, it will take whatever name variable is sitting in the global scope. Now, right after script1, we're loading script2.js, which again declares name in the global scope, which basically means that at this point right here, my name equals Yaakov gets overridden with name equals John. And then we declare another function, which is a little bit of a different name, that says hi, say hi, and that is the one that prints out hi plus name. So by the time we get to say hello, our name variable has actually changed from Yaakov to John. And what's going on is that one script is stepping on the toes of the other, basically. So how do we solve this situation? Well, one way of solving a situation is introduce namespaces. And a namespace is basically just a container for some functionality and for some declarations. The only thing is JavaScript doesn't really have namespaces that other languages have. However, in JavaScript, we could fake namespaces very easily. Let's go to script1.js, and instead of just saying Yakov here, let's declare a variable called var Yakov greeter, and we'll just make it equal to an empty object. Now, instead of just declaring name right here in the global scope, what I'll do is I'll declare name as a property of Yakov greeter. So Yakov greeter.name is Yakov, and the function will be the same way. I'll just cut it out of here, and I'll say Yakov greeter dot say hello equals this function. So now I have Yakov greeter, and I can now refer to the name, and I could refer to say hello as through Yakov greeter. One more thing I need to change is this name right here really should be not just name, but Yakov greeter.name. Okay, so we're good here. If we go to now script2.js, we could do the same thing. We'll say var John greeter, and we'll make it equal to an empty object. And now everything else that we have in this file, we're going to start with, we don't need to declare a variable anymore because we already have one. We're going to start with this John greeter. So here it's going to be John greeter.sayHi, and we're going to take out the say hi out of here. And this again is going to be John greeter.name. Okay, so now that we've converted this to a namespace, and now everything that we are referring to inside this in terms of the variable names and the functions are going to have to go through these namespace objects. So inside our app.js, in order to say hello, that's no longer going to work. So if I go ahead and save this and save that, you can see here now it says that say hello is not defined. Well, it's not defined because in the global scope, there's no such function as say hello. However, there's an object that has this function attached to it. So if I say Yakov greeter dot say hello, and this will be John greeter dot say hello, dot say hi, and I save that, you can see how now it says hello Yakov and hi John. So that worked perfectly. So this is something that you could do in order to separate kind of your namespace and separate your functionality into separate files and also into separate namespaces so you don't step one upon the other. But there's something you could do to go even further in order to separate different variables that are sort of like private variables between different scripts and different execution contexts. And that's what we're going to speak about in part 2 of this lecture. In part 1 of this lecture, we spoke about faking namespaces using JavaScript objects such that certain variables and functions can coexist in the global scope without stepping on each other's toes, so to speak. But there's something you could do to go even further. A lot of the times when you have a bunch of functionality sitting in a script, a lot of it is not really something that you necessarily even want to put into some namespace. Sometimes you just want it to execute when the browser loads that JavaScript. You just want it to execute and kind of go away. So you don't necessarily need to put it in a namespace. So for example, if I didn't want to hardcode the string say hello, if I wanted to, for example, let me cut it and say greeting, and this greeting, I just want to declare as a regular variable. So I just want that to be a string. So I just want to be able to use that string inside of my say hello function. Well, I could do the same thing, var equals greeting, in the script number 2 and say var greeting, except this time I want to say hi and just substitute it with greeting. Well, we kind of have exactly the same problem again, don't we? Greeting now is going to be part of the window object, part of the global object in script 2, and in script 1, it's going to be, again, part of the global object. So once again, I'm going to now end up with hi Yakov, hi John, instead of hello Yakov, hi John. Well, one more thing we could do is introduce something called immediately invoked function expression. Let's go to our app.js, and I'm actually going to comment this out for a minute and show you what an immediately invoked function expression is. I'm sure you've seen a function before that in this course that we've done, where let's say we're just going to go ahead and console.log, say hello Coursera. Okay, so in order to now for us to execute this function, we need to say a and put our parens behind it, right? And go ahead and save that. And now you'll see hello Coursera. And you also remember that I could save this function in a variable. So I could say var a equals function log hello Coursera. And this is exactly the same thing. If I save this, you'll see it will refresh and it'll say again hello Coursera. Well, the way we execute a function is by putting these parens behind its name. Well, remember, function is just a value. This whole thing is nothing more than an object. It's a function object. So technically speaking, I could just wrap it in parentheses right here as just an object, right? So if I save it again, nothing really changes. Well, how do I execute a function again? I execute it by putting parentheses right behind it. Well, then it follows that if I erase this variable right here, I can invoke this function right in line by just putting parentheses right after its declaration. So this function is going to produce, this declaration right here is going to produce a function, and the parentheses right behind it is going to invoke it immediately. So this is what's called immediately invoked function expression, otherwise known as IFE. So immediately invoked function expression. It's an expression because this line right here, or this set of code, is actually something that produces a value. Thus, it's an expression, something that produces a value. Well, what value does it produce? It produces a function object. And then we're taking that function object and we're just putting parentheses right behind it. And that invokes that function object. And therefore, when we save, we're once again going to see hello Coursera. And I could certainly even pass parameters to it. For example, if this function wanted a name to be passed to it, and instead of just saying say hello, I'll just say hello plus name. So if I execute it right now, what do you think it's going to say? It's going to say hello undefined. Why is that? Well, because it's asking for a name to be passed to it, and we're passing nothing to it. So let's go ahead and pass Coursera. And when we save, it will say once again, hello Coursera. So in the same vein, let me go ahead and comment this out so you have it for your record, so to speak. And I will uncomment the greeter. If I do this again, it still say hi and hi. So how can we separate them? Well, if we go to script 1, we could wrap this entire thing with parentheses, function, and wrap this whole thing into a function. So now this whole thing is sitting inside of a function. Technically speaking, I could just indent it a little bit like this. So this whole entire thing is sitting inside of a function. And if I just leave it like this would be kind of bad because all I would be doing is declaring a function. Well, I don't want to just declare it. I actually want this code to execute. So in order to get this code to execute and execute just on load of script.swan.js, all I need to do is put parentheses behind it and put a semicolon. So now this is going to execute the second it loads. Now if I save that, this is not really going to work. Why is that? Well, because in app.js, Yakov greeter.sayhello is undefined, is not defined. So where is Yakov greeter? Because this is at this point is looking in the Windows object to see where Yakov greeter is, and Yakov greeter is not defined there because now we've put it in its own execution context. So Yakov greeter is only living inside of this function. So how can we expose this Yakov greeter to the window object? Well, we could go ahead and pass the window object as part of the parameters to the function, and we'll say window here. And at this point, when we say Yakov greeter, we can even do it right at the end. We could just say window, that's this window right here, dot Yakov greeter equals to Yakov greeter. So now what we've done is we've exposed our Yakov greeter object and we placed it into the window object. We kind of exposed it to the outside. So now when we're in app.js, Yakov greeter is indeed exposed to the outside. So let's go ahead and save that. And now you could see hello Yakov, hi John. And the truth of the matter is, even here, we still want to do the same thing. In fact, let's go do it this way. Usually the way we want to type it up is not try to wrap those curly braces all around. It's very confusing that way. But instead do this. You have parentheses, you know there's going to be a function inside of it, and I know I'm going to want to invoke that function. So really I'm going to put the parentheses right behind it and then put a semicolon at the end. So now all I need to do is declare this function. and the function is going to have the parentheses right behind the word function and curly braces. And now I could just open it up and take this entire thing, cut it out of here, and maybe even indent it, place it over here. Let's indent it a little bit more. And there it is. Except again, the junk greeter, we want to expose that junk greeter to the window object, to the outside. So we'll go ahead and pass the window object here and pass it in here. And now, right at the end, or we could do it right here, it doesn't really matter where, but we could do it right at the end. We could say that window dot junk greeter is equal to junk greeter. So the window junk greeter, we're creating a new property on the window object, and we're setting it to the junk greeter, that is the object that we set inside of this execution context of this function. So if we save that, and now we see hello Yaakov, hi John. So notice we were able to use something that we want to expose outside. In other words, whatever we wanted to expose outside, we simply placed it as a property on this John greeter object. And whatever we wanted to use inside, like a greeting, so like almost like a private variable, we could still use, and we could still use it inside the function, and we don't have to expose it to the outside. And at the same time, this greeting was not going to collide with this greeting inside the Yaakov greeter, or inside this function, basically, but not inside the Yaakov greeter, just inside this function, because each one of those variables is being defined in their own execution contexts, meaning in this function, and this greeting is being defined in this function. So what we've done is we've learned about namespaces, or at least how to fake namespaces in JavaScript, which is totally legitimate, and we also learned about how to utilize immediately invoked function expressions. Congratulations on completing Module 4. While I didn't cover everything there is to know about JavaScript, since JavaScript is only one topic in this fairly short course, we did go pretty deep, and what we did cover should give you a very solid foundation. I would actually bet that even some seasoned developers don't know all the topics from this module. In the next module, we'll start applying JavaScript to creating web applications. Keep going, you only have one module left to go, and you complete the entire course. Welcome to Module 5, the last module of this course. Now that we've learned JavaScript language fundamentals, we will dive into using JavaScript to manipulate elements within our web page, as well as use Ajax to pull real data from a server without the need for the user to reload the entire page. We'll finish off the module by using our newly acquired JavaScript and Ajax skills to complete the restaurant website so it pulls its content and menu data from the server and dynamically generates HTML for the view. See you in the module. JavaScript in the browser wouldn't really be any fun if you wouldn't be able to manipulate the page that JavaScript is attached to. So in this lecture, we're going to speak about DOM manipulation, otherwise known as document object model manipulation. So the first question that comes when we start talking about DOM manipulation is how to include the actual script.js, how to include your JavaScript library inside your HTML page. Currently, I'm looking at script.js, which is located in the Lecture 53 folder. And I'm going to go ahead and close the file browser so we have some more space here. And before we even start going on about where to include the script.js, let's go ahead and learn about this special object called document. And the document object represents the entire HTML document, the document object model. So we know that there's an object called window, otherwise known as this, and it contains a whole bunch of things. One of the things it contains is a document property. So if we go ahead and say, let's clear this, and say window.document, you'll see that what you get is a document object. And if you open it up, you can see that the document object contains our entire HTML page. This document object is the stepping stone for us to be able to get at individual elements within our web page. And there's a few ways to do that. So let's go ahead and take a look at our index.html just to familiarize ourselves as to what's going on here. So what we have here is a very simple page. It has an h1 title, which just says lecture 53. We give it an ID called title. Then we have a paragraph that says say hello to, and we have an input field, again with an ID name. It's a type text, so it's going to display a text box. And we also included a button that just says say it. And then at the very end here, we have this div that is an empty div that just has the ID content. And we'll see why we need that a little bit later. So one of the central methods that the document object has is being able to get at the element by the ID. So let's go to our console and let's try to get at this h1 element right here. So the way we could do that is by this special method called, let's go ahead and say document dot get element by ID. And in parentheses, we're going to specify the actual ID in quotation marks. But the ID is going to be without the pound sign. It's just the actual ID. In this case, it's just title. So if we execute that statement, you'll see what returns is the element h1 that has the title ID. Now, of course, we could do console.log inside our script.js to accomplish exactly the same thing. So let's go ahead and try that. First, let's include script.js, which is located in the JS folder, inside our head section of the document. So we'll say script, and we'll say source equals, so it's JS script.js. And we can omit the type attribute here because JavaScript is really the only type that's possible here. So go ahead and save that. Let's go to our script.js and execute exactly the same thing. Let's go say document dot. Now the reason we're able to use document here is because we're in a global scope. The global scope is window. And window has an attribute, has a property called document in it. So when we say document, this will obviously go ahead and look on the window object to see if document is one of its properties. And in fact, it is. So document dot get element by ID. And we're going to say title. Let's go ahead and console.log this. So let's see what happens when we do that. Let's save that, and we'll get null. Well, that's kind of strange. Why would we get null? Why are we not getting this lecture 54 or lecture 53 title? Well, the reason we're not getting it is because of when this line is being executed. Let's take a look at our index.html again. This line is executed just like any other JavaScript, is exactly where it is mentioned. So it's as if we took this line right here and we copy and pasted it right in the middle of the script tag. Well, the problem is that when you're calling and asking the document to retrieve for you something that has an ID title, at this point of the rendering of the HTML page, the h1 with an ID title doesn't exist yet. So therefore, you get null. So how do we solve that? Well, there's actually a couple of ways of solving it. One is to have a special method that listens for an event in the life cycle of the page loading and says when page is loaded, go ahead and execute this line. However, there's even a simpler way to fix that, especially the fact that what we're trying to do is insert some behavior into the page. It's not how the page is going to look, it's how the page is going to behave. And whenever things like that, JavaScript code like that is executed, it's always best not to keep it in the head, but actually place it at the very end of the document. So which is what we're going to insert right here. So this JavaScript is going to execute after all of these things have been already processed, loaded in the browser's memory, and the document object model is now going to be alive and well. So now if we save that, you'll see that now we are getting, at this point, the h1 that has an ID equal to title. So this code executes just fine only when this element has already been loaded and rendered. Now the reason we're able to use this function called get element by ID is because document is a special object, and the object name of the document is HTML document. It's a special object that has a whole bunch of different methods that you could call on the document. So in fact, we can actually console.out, console.log, document and find out, is it an instance of? It's an instance of operator that we actually haven't seen before that tests whether or not a particular instance is actually an instance of a particular class. In this case, it is HTML document. So if we print that out to our console, let's save that, you'll see that that's true. So document is actually an instance of HTML document. So if you go on the web and look up HTML document, you will be able to see all the methods that HTML document defines for you to help you manipulate the web page. So now that we know about this special object called document, otherwise known as HTML document, in part 2 of this lecture, we're going to start using this special object to manipulate the web page. In part 1 of this lecture, we learned about a special JavaScript object called HTML document that allows us to manipulate the web page. In this lecture, we're going to use that object to actually do just that. Let's go ahead and comment that out for now. And let's turn our attention to index.html. We have this paragraph here that says say hello to, and it has an input element and a button. Now the button is not really going to do anything, as you can see right here. As much as I click it, it won't really do anything because no behavior has been really assigned to it. Now we're going to have a whole lecture on event handling, but for now, let's assign it some simple behavior. And one of the ways at least you do it, is you could say onClick, which is an attribute that exists on basically every single element in the HTML document. And you can assign it some functionality in it. So in other words, you could call a JavaScript function in here. So we'll say hello. We'll call a function say hello on click of this button. Let's in fact actually put it right here so we could see it a little bit better. So on click of this button, we're going to call a function say hello. Let's go ahead and define the say hello function. Let's save that. And if I actually go ahead and click this now, we'll get an error because say hello is not defined yet. Let's go ahead and define that say hello function. So let's say function, and the function name is going to be say hello, and we don't need any arguments for now. And for now, in the body of this function, all I want to do is be able to retrieve the value that the user typed in into this text box. So how do I do that? Well, I can once again use my document. Let's do console.log. And once again, can use my document. Let's give some spacing over here. Document.getElementById. And I could say, what ID do I want? Well, let's go take a look at our HTML. And the ID of the input element is name. So I could go ahead and copy that. And I want getElementById name. But if I just do that and leave it alone right this way and save that, now when I click save, what I'm going to get is I'm going to get the actual element. Well, I don't really want the element. I want the value inside the element that the user typed in. So the way I do that is by accessing the value property, .value. When I do this and save it, so now if I say it, nothing is really going to show up because I didn't really type anything, but I'd say Yaakov and say it. Now Yaakov value is going to show up. Now my ultimate goal here is that the web page in this space right here should greet me, say hello Yaakov. So one of the ways I could do that is, first of all, save the value that I retrieved from the input element that the user typed in, save it in a variable. So let's go ahead and do that. Let's say var message, or let's say name actually, and let's go ahead and erase this. Let's see if this will fit. No, it doesn't, so let's go ahead and just put it in the second line. And we'll just say var name equals, and we'll retrieve the name that the user typed in. Okay, so far so good. Let's go ahead and define a message, and the message will be hello space plus name that we retrieved plus, and let's give it an exclamation point. Okay, so now that we have the message, it's time to actually insert this message somewhere here. How do we do that? Let's take a look at our HTML document. There's this div that we defined and left completely empty, and it has an ID called content. Okay, so that means we could retrieve it as well. Okay, so let's go ahead and do that, and we know how to do that at this point. We could say document.getElementById, and the ID was content. So how do we now insert things? It wouldn't be that value because that's only for input elements, and a div is not an input element. But there is a property to be able to insert text inside of an element. So let's go ahead and actually put this on a separate line so I could see it a little bit better. And the value is text content. So if I say text content and say the text content is equal to message and put a semicolon after that and save that. So now when I say Yaakov and say it, this message shows up. And in fact, if we actually inspect the element, let's go ahead and do that. And you could see, let's lower this a little bit somehow. You could see that we have div id equals content, and inside of it you see hello Yakov. Now that's all great, except now what I really want is I want this Yakov to be an H2. This is lecture 53, that's an H1. I want the Yakov to be an H2. Well, let's try to see if we could do that. Let's go back to the console, and let's just augment this with a H2, and we'll close H2 right here to make it into a string. Okay, so now if we save that, let's say again, Yakov, and we'll click say it. Not quite what we wanted, right? H2 thinks, or at least the browser thinks, that this H2 is just text, not really something that the browser should render. Well, we can actually fix that because there's another property that tells the browser that what I'm inserting is actually HTML for the browser to render. So let's go ahead and copy this and comment it out, and we'll have another line that looks almost just like that, except the text content is going to be replaced with another property called inner HTML. So when we say inner HTML, the thing that gets assigned to it is going to be interpreted as HTML and therefore rendered. So now if we save that and type in Yakov right here, and now we see that this is now in fact an H2. So if we inspect the element, we could see here now that the div with ID content has an H2 inside of it that is actually being definitely rendered as an H2. Now, believe it or not, armed just with this knowledge alone, you could already do quite a bit inside your HTML page. So let's go ahead and put some behavior into this that has a little bit more smarts into it. I want this thing to say hello, whatever the name is that the user provides, unless, of course, they say hello student, in which case I don't want it just to say hello student. I want that value to trigger a side effect to the page and change our title a little bit. So how can we accomplish that? Well, we could definitely test inside the say hello method or say hello function. We could test if name, let's move that all the way here. If name is equal triple equals, because we want it to be a string, equal to student, then I want to do a couple of things. Number one is I want to retrieve what this title is because I want to add a little bit of a string right here. I want to add something else to it. I want to say lecture 53 and something else. So the way I do that is I could say var title equals, and at this point let's go ahead actually and put it on the second line and say document dot, and we can, if we wanted to, say get element by ID right here and basically specify title, because if we look at our index.html page, our title, our h1 has a title as an ID. However, there's another method that's very worthwhile for you to learn, and it's much more generic than get element by ID, because get element by ID really just restricts you to be able to select things within your page by ID, but you might want to be able to select it by other things. So like, for example, the way you select things using CSS. So the method we could use instead of get element by ID is called query selector. And in this case, query selector takes not the ID name, but actually a selector. So if we wanted to select it by ID, in this case title, you would do the same thing you would do in CSS by selecting this element. Well, the way you would do that is you would actually specify # title, right? Because that's a CSS selector, not just title itself. So this should go ahead and grab the h1 element out of our HTML page. Except we don't just want the h1 element, what we want is the text content of the h1 element. So let's go ahead and say dot text content, and that will be the value of our title. So now all we want to do is now we want to augment the title a little bit. So let's go ahead and say title plus equals, you've seen this before, it just means title equals title plus something. But the easier way is just to say plus equals. And we're going to add something. Let's say, and loving it. So it's lecture 53 and loving it. So the student is really loving it at this point. Am I correct or am I correct? Anyway, so let's go on. So now let's go ahead and save this, and we'll go ahead and put name here. Well, if I put Yakov, right, it will just say hello Yakov. But if I put student, got to spell it correctly, and say hello student, but nothing really changed here. Why is that? Well, that's actually simple, right? Remember pass by reference, pass by value, or copy by reference, copy by value? Well, this is a primitive, and we're copying a primitive out of text content into this title. So therefore, when we change the title, the text content property is not changed at all. What we actually have to do is turn around and explicitly set it. So let's go ahead and grab this whole document thing right here, and we'll put it over here, and we'll say text content equal to title. That's the new title that we've updated right here. So now when we save that and go ahead and try it with, let's say, Yaakov, and if we say click say it, we'll see hello Yaakov. But if we actually put student in here and click say it, now we've not only said hello student, but we also have updated our H1 title, and now it says lecture 53 and loving it. Now, the last thing I want to point out to you is that this is a selector by ID, but we don't have to select it by ID because this is nothing more than using CSS selectors to select elements within our page. Well, if we take a look here, we could use something else. We could use the fact that there's only one H1 element in the entire page. So if I wanted to, I could simplify this by saying H1. So I erase this and just say H1. So H1 is the only element that this is going to select. And in fact, if there would be more than one H1 element in my HTML page, what this will return is the first matching element. If you wanted the list of elements that matches a particular query selection, you would use a different method. I believe it's called query all selector. So anyway, so at this point, we just want one. So if we say H1, this will accomplish exactly the same thing as calling it by title. So if we save that and test it out by saying student and click say it, and you can see this works just the same as before, and it's lecture 54 and still loving it. We've already seen a simple example as to how to bind an event handler to a particular element. I'm located right now in the index.html in the lecture 54 folder. Let me go ahead and close the file browser so we could see a little bit better. So you remember this HTML document, we had a button in the middle of here that says unclick equals say hello. And as you can remember, when we entered some name over here and clicked say it, it will say hello Yaakov using this say hello function. I'd like to explore now a couple of different ways that you could actually assign event handlers to elements. Now, first of all, what are event handlers? Well, event handlers are basically functions that you bind using specific methods to certain events that happen in the browser. Now, those events might be triggered by just the lifecycle, meaning something like the page loaded. That's an event. Or it could be triggered by user interaction, like a user typed a character or a user clicked something. So one of the most simplest ways to assign an event handler to a particular element is to just use the onSomething attribute on that element. So here you could see that we're using onClick and we say hello, executing that JavaScript function say hello. But the truth is, if you take a look, there's a whole bunch of these, and they really have to do with keyboard and mouse events as well as focus events. So for example, onBlur means when this particular element loses focus. So I can actually go to my input field here and say onBlur, and we'll say hello. Well, the same function will execute when I type something in here. Let's go ahead and refresh the browser. And I'll say Yaakov, and the second I lose the focus from here, like that, so let's go ahead and save our index.html, and this will get reloaded. So if I go and type in Yaakov, and the second this field loses focus, you'll see that say hello will get executed, and hello Yaakov will appear. So let's actually erase that for a minute so we don't crowd our space here. So placing an onClick on onBlur or on some event straight on the HTML is one option. Now that option comes with some side effects. One side effect is that you kind of have to dirty up your HTML with these onClick, onBlur, onKeyDown, and so on these events. And typically, and as we've been speaking about it before, HTML is really just for content. It's not really there for behavior. So that's one difference. Second difference, let's go ahead and save that. Second difference is this. If we go to the say hello function, which is what we're executing when somebody clicks the Say It button. And we go ahead and console.log this. What is this pointing to? Let's go ahead and save that. And we don't have to even enter anything here. We'll just click Say It. And it's apparently pointing to the window object. So why is that? Well, since this say hello function is being defined in the global context, it makes perfect sense that when we say this will be pointing again to the global context, which is the window object. And since in here we're not doing anything at all by assigning this to this onClick attribute, we're not doing anything at all to change that context for this hello function, we actually are executing it right here. So that remains the same. However, there's a different way of doing the same thing, that is binding this function to the click event. Let's go ahead and take a look at another way of doing this. In this way, it's called unobtrusive event binding. And the reason that's called that way is because the HTML doesn't really need to know anything about your JavaScript. So let's go ahead and go to the HTML and let's go ahead and erase this out of here. So now the HTML doesn't know anything about the click handler. Let's save that. Go to the script, and here's what we're doing here. We're saying document query selector button, so we selected that element, and we're calling this function called add event listener, and we're saying that I want you to listen for the click event, and when that happens, I want you to use this function expression or this function value, which is say hello, which is pointing to our say hello function. Now when we do this, let's take a look as to what this now is going to point to. Let's go ahead and let's save the script, and let's go ahead and click say. And obviously we didn't provide anything, but as you could see, this now is pointing to the actual button. And that makes perfect sense since we're passing the value of this function into this particular element. So this element button gets a call called add event listener, and inside of that call we somehow assign this say hello to its event. So therefore this variable is now pointing at the containing object, which at this point is the button element. Now there's a similar way to assign that click handler except using the onClick property. Let's go ahead and comment this out and uncomment this line right here. And I can see there's a typo in here. It really should be onClick. So point is, whatever the onClick, onBlur, on something that you have available on the element itself, you could use that as a property of the object that you selected. So in this case, we're selecting again the element object, and we're setting its onClick property to be the value of the function say hello. Again, it's just a value. We're not providing parentheses here after the function. We're not executing it. We're just setting its value to it. So what do you think the say hello function is going to say when we say console.log this? Well, since this is pointing or is being executed inside of an object that is the button object, when we go ahead and click say, it's going to be once again a button object. And you know, while this way might seem a little bit more complicated to assign event handlers than simply just saying on click over here, it does provide us a little bit more flexibility. Let me show you what I mean. So let me go ahead and comment this out and leave just the add event listener way of editing the click event. So what I'm going to do now is I would like to do is as I'm typing this, when I say Yaakov and I click say it, I want the name of the button or the label of the button to change. Well, that's very easy to do if the this variable inside of the event handler already points directly to the target element that you're working on. So let's go ahead and go here and say that when this happens, I'm going to go ahead and say this dot text content equals to set it. So we're going to say that the button set it already. So when I save this, and I say Yaakov, and when I click say it, it will change to set it. And that's a much more convenient way of doing things instead of having to once again select using the query API, select this button and change its label. And that's because in this JavaScript, I don't really have to know what triggered the click event. If I had to do it the other way, I would have to know that the button is the one that triggered the click event. In this case, I don't need to know that. I just need to know that something that has text content triggered that particular event. Let's discuss one more event that is a lifecycle event of the page that will let us actually assign the events to the elements of the page once they load, but before anything else loads, before any images load, before any CSS loads, and so forth. And since we're going to be listening for that event, we no longer need to provide this script at the bottom of the page. We can actually cut the script out of here and place it very easily in the head. And let's save that. And now what we need to do is we need to actually listen for a particular event on the browser lifecycle. And that event is called, let's say, document.addEventListener. And the event is called DOM content loaded. And what we want to do is we want to assign a function. Let's go ahead and put our semicolon. And what we want to do is we want to assign a function, and we need a name. And every event handler function gets this event object. So, and inside this function, we can now start assigning different events. So what we can do now is we can create this function hello and grab this whole text right here, cut it out, and place it right here. And maybe move it over a little bit. Okay, so now we have the entire function sitting inside of addEventListener, and it will get executed. This function will get executed when this event fires called DOM content loaded. And that will happen before any images or any CSS or any other script is loaded. So if we save it and say Yaakov, click say it, as you can see, we still have our functionality working just as before. Except this time, we didn't have to put all this code at the very end when all the elements have loaded already. Instead, we're listening for the event when all those elements have loaded. And in that case, we're able to execute these functions and get element by ID and be sure that these elements already exist in the document object model. There's an argument that's passed by the JavaScript engine into every single event handler, and this is something I kind of glanced over in the previous lecture, so let's talk about it now. I am located in the script.js file, which is located in the lecture 55 folder. Let me go ahead and close the file browser of Sublime, and let's the first thing we'll do is let's go ahead and log the event. Let's go ahead and say console.log, and let's go ahead and log the event. We print it out, and let's say it, and we see that the object that event is a mouse event. If we open it up, actually, we'll see there's a whole bunch of properties that this mouse event has. It's a client X, client Y, where this was, where the X and Y coordinate was on the page. There is the movement, page X, there's the path, there's the screen X, screen Y, which is the location of the X coordinate vis-a-vis the entire screen. There's the shift key, which tells us whether or not the shift key was being pressed down at the time that the click happened. So even though we haven't really used the event object, this is something that's passed into every event handler. Let's take a look at the API documentation for event, and we'll see what it actually gives us. Let's go to the event. And this is the event page of the Mozilla Developer Network. And it talks about all kinds of events that can happen. And obviously, depending on the type of event that happens, either a key press, so it's some kind of interaction with the keyboard, or a mouse press or a mouse move, which is interaction with the mouse, you're going to have different types of events. It's going to be different types of objects that contain different type of properties that are related to that type of event. So you can see here, for example, we have a keyboard event object that's probably related to keyboard events. And there's also a mouse event object, and again, that's related to the mouse events. So I clicked on it, and it gives you a whole bunch of different properties of the mouse event that is passed into you and explains to you every single one of them as what they do. So there's the client X and client Y. And it tells you the client X is the X coordinate of the mouse pointer in the local DOM content coordinates. If we scroll down, there's also should be a shift key, the shift key property, and it returns true if the shift key was down when the mouse event fired. Now there are different types of mouse events. There's mouse out, mouse over, mouse move. If we click on mouse move, basically what it tells you is that mouse move event is fired when a pointing device, usually a mouse, is moved while over an element. Let's go ahead and try to implement a different type of behavior. Let's go ahead and implement a console.log. We're going to log to the console client X and client Y position of the mouse pointer, but only when I press the shift key and move the mouse over any part of the body element. Let's make this back into a little bit of a smaller screen. Let's go back to our page and we'll go ahead and clear that. So what we're going to do is we're going to create yet another event listener. So here we have an event listener called say hello, and we're actually assigning it right here, and we're going to create another one. So, and we're going to create another one exactly the same way. We'll say document dot query selector, and this time we'll say on the entire body. And I want to add event listener, and event listener I want to add is mouse move. So it's mouse move, and notice since I'm using the add event listener, it's not on mouse move, it's just mouse move. And then let's go ahead and put a semicolon at the end so we don't forget. And then what we're going to do is we're going to create a function, and the function is going to get an event, obviously, by the JavaScript engine. And in this function, what we want to do is we want to do console.log the event.clientX, and again console.log event.clientY. So if we save that now, and as I start moving the mouse over, you will see that we're logging where my mouse is moving. We're logging the X and Y coordinates. Now, we didn't really specify what they are, so it's a little hard to tell. It's probably a better idea to do something like this. X is this, and Y is that. That's probably a little bit better. So now when we mouse over, at least we see X and Y. Okay, but what we wanted to do is we wanted to only log this when I press the shift key down. So in our function, in our event handler, what we're going to do is we're going to put an if statement. We're going to say if event.shift, and I can't remember what the name is, so we'll go ahead and look this up. Let's go back and look up the property names called shift key, just like that. So we'll say event shift key equals true. If that's the case, that's when we're going to log this. Otherwise, we're just going to ignore this mouse move event completely. Okay, so we'll do this. We'll position it like that. And now let's go ahead and save that. Let's go back to our browser. And now if you see when I'm moving my mouse around, nothing really happens. But if I press the shift key, which obviously you can't see, and start moving the mouse around, all of a sudden the mouse move is printing out the client X and client Y coordinates. So if I let go of the shift key, see, the mouse move event handler is no longer printing out the X and Y coordinates because the if statement is basically saying skip it because the shift key property is not equal to true. Before we launch into discussion about AJAX, which is essentially a client-server communication technique, let's talk about the language in which the client, that is the browser, communicates with the server. And the language that they use, otherwise known as protocol, is HTTP. So let's talk about some HTTP basics. Number one is, what is HTTP? Well, HTTP stands for Hypertext Transfer Protocol, HTTP, and it's based on a request-response stateless protocol. And stateless in this context means that when the server responds to a request from a browser, that response does not depend on any previous requests that the browser made. In fact, as far as the actual language in which the client, the browser, and the server communicate, the server has no idea whether or not the client or the browser has requested anything from it before. Now, obviously, in the real world, you need to be able to know that if I clicked to buy a book 2 minutes ago, that when I go to my shopping cart and want to check out, that I'm the same person who clicked to buy the book. And it's a little bit outside of the scope of this course to explain how that works. But the protocol itself, the HTTP protocol, is stateless. There's nothing inherently in it that remembers that you are the same person who requested or made that request between the browser and the server a couple of minutes ago. So the way the client-server communication works is as follows. The client, the browser usually, opens the connection to the server. Then the client sends an HTTP request for a particular resource. And then the server responds with an HTTP response to the client, usually with the resource that the client requested, but sometimes the resource is not found or some other error occurs. And then the client, that is again the browser usually, closes the connection to the server. Now, before we speak about the actual communication language, the HTTP protocol, for a little bit, let's talk about how to identify a resource on the web. And when we talk about it, we have three terms that we need to understand that are kind of thrown around, and it's a good idea to understand what they mean. The first one is Uniform Resource Name, otherwise known as URN. What a URN is, it's a way to uniquely identify a resource or name of a resource. The thing about URNs is they do not tell us how to get that resource. And URNs are very commonly used by organizations and institutions who want to standardize to maintain some uniqueness of a particular resource within that organization. So for example, if Coursera wanted to maintain unique names for each course that they have, they could make my course or this course you're taking and could generate a string that says HTML, CSS, JavaScript, well, developers, Yakov Heiken with the slashes in between, and it will probably uniquely identify courses or this course within all the other number of courses that they have on the platform. It will not obviously uniquely identify my course all over the world, but it might uniquely identify it within the Coursera platform. Another term is URI, and URI stands for Uniform Resource Identifier. And what that does is uniquely identifies a resource or a location of a resource. But even though it identifies uniquely the location of a resource, it still does not necessarily tell us how to get to that resource. And the reason it doesn't is because within a URI, the context is usually missing. It's very similar to URN, except the URI is much more directory type of structure looking thing. So for example, a URI might be /official_web_site/index.html. While if I'm sitting at Coursera.org, this will mean a unique URL put together with the Coursera.org. But if you just give me the URI itself, it doesn't really tell me where to get it. And if you just come over to me and give me this URI, official website /index.html, I will not be able to get that resource because I won't know where to go to get it. Once you kind of take me to where to get it, if you take me to Coursera.org and I start from the root of Coursera.org and I could start searching /official website /index.html, then I'm able to get it. But URI by itself doesn't necessarily tell us how to get that resource. The last final term is URL, and that stands for Uniform Resource Locator. And this is something that's obviously thrown around on the web all over the place. When you ask somebody for a website address, it's a URL. It's a Uniform Resource Locator. And URL is a form of URI that provides the information on how to get that resource. So for example, if you tell me that it's http www.mysite.com /official website /index.html, I know exactly where to get it because mysite.com only exists in one place. So I know where to go to get that resource. So let's take a look at an HTTP request structure. In other words, the actual language that the browser communicates with the server. And this is an example of a GET request. So this request starts with the word GET, and it's almost like a command. I want to get some particular resource. And that command is called a method. And there's many methods, and we're going to talk about a couple of them. Then follows the URI string. So this command has particular parameters you have to pass it. So it starts with a GET, and then you pass it a URI string. And then you pass it a query string, which is not a requirement, but a lot of times you do see that. And a query string is nothing more than a name-value pair separated by ampersand. So for example, in the orange box, you could see that question mark, which is something that starts the query string. And you see first equals Yaakov, ampersand, last equals Heiken. So those are two name-value pair parameters. And the last part of this command is HTTP / 1.1, and a long time ago already at this point was HTTP 1.0. It's the HTTP version, the version of our language. So this is the command that the browser issues to get at a particular resource on a website. I'm sure looking at it, you could start seeing that there's something strange about this command. Where is the website name? How do I know it's a URI? It's not a URL. And the reason it's a URI, not a URL, is very simple. This command is only issued once the browser actually connects to the server. So we're already connected to Coursera.org or to mysite.org. And now that we've connected and established a connection to that particular website, now we're asking for a URI within the context of that website. And the way we ask for it is using a particular language. And that language is called the protocol. It's the HTTP protocol. A good analogy would be if you and I both speak English. That's our language. That's our protocol. When I say hello, you say hello back. However, it's no use for me to stare at my phone and keep saying hello to you if I've never even dialed your number, right? The first thing I need to do is I need to dial your number, connect, our phones need to connect together, and once the connection is established, I could then ask you and say hello and ask you questions. Before then, I really can't do anything. Well, very similar to here. The browser first has to make a connection to the server, and once it makes the connection, it starts the HTTP protocol, starts the language of communication between the browser and the server. So what you see in front of you on the slide now is kind of a GET command, otherwise known as a GET request, and it's named after the method or the command that is issued as the beginning of this line. Now, there are a number of these methods, and let's go ahead and take a look at a couple of them that, at least for us, is going to be pretty important. One of them is, again, the GET command or the GET method. And what that does is it says, I want to retrieve the resource from the particular location. And the way you pass the data using that method is you pass it to the server as part of the URI. As you remember, we had the query string. Well, that's how you pass the data. And the data is not so much to be stored on the server as much as really a way for us to tell the server and identify a particular resource or maybe filter a particular resource, the data from that particular resource. So we need to pass the data to the server in order to get the data back. It's not really for the server to store it necessarily. The other command or the other method, HTTP method, is post. And this method sends the data to the server in order to be processed. And the data that you send to the server is sent in the message body. Now, the server may still respond, and most of the time does, respond with some sort of response, maybe an HTML page, maybe some sort of data, but that data is more viewed as a status or kind of a confirmation that the data that you sent to the server was in fact processed, whatever that means, stored or some other side effect happened because of it, but it's an indication that it was processed. Now, there's many more methods that we're not covering here, but these are good enough just to get an idea of the actual protocol. So when we talk about post request and the data being sent as part of the message, let's go ahead and quickly visualize what that looks like. So this is a typical post request. And you can see there's a post / index.html, but there's no query string. The query string and the data that we're passing comes as part of the body of the message. So there's a few parts here that actually exist on pretty much every post request, which is the first line, the post request itself, followed by some request headers. In this example, except character set is telling the server that our browser knows how to process UTF-8 character set. And after that, we have the message body. This is where the data is being passed to the server. So this is the post request. Let's take a quick look as to what an HTTP response structure is like. Well, it starts with just a response status line. And the response status line has three components. First one is the HTTP version. So the server kind of spits back out the version of HTTP it's communicating. The second is the response status code. And the third is the English phrase describing that status code. and all three parts are separated by a single space. So a typical HTTP response may look something like this. It will start with HTTP 1.1, 200 OK. It will follow by some HTTP response headers. In this case, it'll tell you what the date of this document is. It will tell you the content type. In this case, it's text and HTML. And then the body of the message, or the body of the response, will be HTML. Now, the message body of the response need not be HTML. It can be, for example, plain text, XML, or JSON, something we haven't really talked about yet. So let me show you some common response status code. One of them is 200 OK, and that basically means that the server is saying, OK, I got your request, and here's the content you requested. Another one is 404 not found, and in this case, the server says, I just can't find the resource that you requested. 403 forbidden. And that means that for whatever reason, the server thinks that the client, your browser, is unauthenticated and tries to access a secure resource that requires some sort of username and password or a certificate or something like that. And another one, pretty common, is 500 internal server error. And usually that happens when some error was raised in the server and was unhandled in the server, and it kind of spilled over, and now you as the user, probably in the browser, are seeing 500 internal error. So in summary, it doesn't take a rocket scientist to understand that if you're going to be doing client-server communication, you need to understand at least the very basics of HTTP protocol. Now remember, the GET methods sends the data to the server as part of the URL or part of the URI. That's going to be important for us as we move forward. And the post method sends the data as part of the message body. And some common response codes are 200, it's fine, the data is coming. 404, it's not found. 500, there's some internal server error. So now we're ready to speak about some AJAX basics. So what is AJAX exactly? Well, the word AJAX used to stand for asynchronous JavaScript and XML. The thing though is, while AJAX started with XML, and that was the data type that was being sent over the wire between browser and the server back and forth, very few apps actually use it nowadays. Instead, most of the time nowadays, plain text, sometimes it's just regular HTML, and then JSON, which we're going to talk about later, is used instead of XML. Now, why does AJAX exist to begin with? Well, we can answer that question by taking a look at how traditional web applications worked and what their flow was like. The traditional web application started with a web page, and usually a user is going to press a button, and that is going to generate an HTTP request that is going to be sent to the server. And the server is going to respond with some response, which is going to be a whole new page. And that whole new page could be basically 199% identical to the original page. And there might be only one string really that changed between the first page and the second page. But in the traditional web app flow, the entire page with all the same elements need to be returned anyway, just to display a minor update. Now in the AJAX web app flow, you have a web page, and it also makes an HTTP request, and that is usually sent by JavaScript, and that HTTP request is sent by JavaScript, and the server also replies, and its response is a small piece of data that's inserted usually into the current page. And the only thing that changes is some minor piece of data. Now, obviously, this is way faster. The response is faster. You use less bandwidth because only one small piece of data is returned. And obviously, it's a much nicer user experience as well. Now, before we go to the process of how AJAX works, let's remind ourselves what is synchronous versus asynchronous execution, since AJAX has asynchronous as its first word. So what is synchronous execution, first of all? Well, synchronous execution is execution of one programming instruction at a time. What that means is that you can't start execution of another instruction until the first instruction has finished its execution. On the other hand, in the asynchronous execution, what that means is that it's execution of more than one programming instruction at a time. Asynchronous instruction returns right away. It sends off its instruction and it's ready to execute the next one right away. And the actual execution of that asynchronous instruction is really done in a separate thread or process. So at this point, you might be wondering, If JavaScript is a synchronous language, everything in it is executed synchronously, how is Ajax even possible? Ajax is asynchronous. Well, let's take a look at a diagram. While the JavaScript engine lives in the browser, it's not the only thing that lives in a browser. There are other components, software components, that also live in the browser. For example, you have an event queue that is responsible for handling and queuing events like a mouse click or browser load or something like that. You have an HTML rendering engine that is responsible for taking HTML and knowing how to display it in the browser web page. You have WebGL, which is responsible for letting JavaScript reach out and do some really higher end graphics work. And you also have another component that, let's call it HTTP requester. And that component is responsible for making HTTP requests. And while the JavaScript engine itself is synchronous, HTTP requester is certainly not. HTTP requester is asynchronous. So armed with this knowledge, let's take a look at the Ajax process. So we have the JavaScript engine and we have this HTTP requester component. And the JavaScript engine is going to have some JavaScript line of code being executed, then another JavaScript line of code being executed, and then finally it comes to a JavaScript line that executes an Ajax request. So what happens at that point? Well, at that point, the Ajax request uses a special JavaScript object to reach out to the HTTP requester component. And notice what I'm indicating here on the slide is that the next line of JavaScript code executes right away. The response of the HTTP requester is not waited on. Instead, when we make the actual Ajax request and reach out to this HTTP requester component, along with our request, we pass in an address of a JavaScript function that is going to serve as the response handler for when the response from the other server or this HTTP requester comes back. However, meanwhile, we continue on our merry way, and the JavaScript engine keeps executing one line at a time. At a certain point, it's executed all the code it can, and its execution stack is empty. If at that point the HTTP requester is done and has received its response from our server, it may at that point use that address of that JavaScript function that we gave it to start with and reach out back to the JavaScript engine and execute the handling of the response. And that's the callback function. That's the function that's going to handle the server response. So that's the basic Ajax process. And that's really enough of the theory. And in part 2 of this lecture, we're going to jump into the code editor and see this in action. In part 1 of this lecture, we spoke about the theory behind the Ajax call to the server. In this part, we're going to speak about the actual practice of it and show you some code to do it. So right now I'm located in lecture 57, so that's lecture folder 57, and I'm looking at actually quite a few files here. And there's a couple of new files that I want you to pay attention to. Number one is ajaxutils.js. And this is the file which is going to give us the JavaScript in order to make those Ajax calls. So we kind of separated it into a separate file so we could see the Ajax procedure in its entirety and then just use it inside the script.js. Notice that in HTML, the index.html, I placed the Ajax utils.js above js/script.js is because script.js uses things inside of Ajax utils.js, which means that I actually have them, I have to have them loaded in the browser already before I start using them inside. So that's why inside script.js, that's why I placed them above that. Now, unlike previous examples where we had the web page click and say hello to whoever was the name that was in the text box, this time we want to click and say hello and get the name of the person we want to say hello to from the server. And for that, I actually have something, a little data file in the server. It's sitting inside the data folder in name.txt, and all it is just says Yakov Chaikin. There's nothing else to it. It's just simple text file. And I want to verify that I can access or grab that file or the data from that file through the browser while my browser sync is running by simply putting the URL in and saying data, that's the data folder, and it's name.txt. If I say press enter, and I see that that's exactly what gets returned. It's a very simple two-word string. So we could close that for now. Okay, so let's close the file explorer in Sublime Text and let's go to our ajaxutils.js. So the first thing I want you to notice is that I'm using the IIFE, the immediately invoked function expression in order to wrap my entire code. So it comes from all the way here, if I scroll down, all the way here. And I'm passing it the window object, that's my global object, and that's how we remember it right here, global. And then what I'm doing is I'm setting up a namespace for my utility. So this is Ajax utils, and all it is just an empty object. So I can then attach things that I want to expose to the outside world. And you could see the very first function here is not attached to my Ajax utils, which means that when I expose Ajax utils to the outside world, meaning outside of this IFE, this function will not be directly available to the user of Ajax utils. Okay, so let's go over what this function does first of all. Well, it says it returns an HTTP request object. And what it does is it checks what type of object is available to us. Now, the very first if right here is the most important one because this is the most current object or the most current version of the Ajax object there is. The rest of them are kind of for the old browser. So window.activex object, that's something old Internet Explorer browsers used and really is not used anymore. And if you wanted to, you could really probably take out this whole thing out of here. Very few Microsoft Explorer browsers out there that are that old. And the last thing is just in case there's a browser out there that's going to access this that does not support Ajax at all, which means this object will not be available, neither will this object be available, we're going to go ahead and pop up a message, an alert here on window object, which is what this global is pointing to. And we'll just say Ajax is not supported, not necessarily the best message to return, but it's good enough. It's probably never going to happen anyway. And instead of the object, we'll just return null. So point is, this is that object that we could use to make requests, and we're creating here a new XML HTTP request object. And this is what we're going to use in our main function that we're going to write in a minute, we're going to see in a minute. And the reason we really pulled it out into a separate function is because it's just easier to put all these if statements in a separate place so we don't have to deal with it right in line with everything else. Okay, so let's take a look at the main function that we really care about. So that function is attached to Ajax utils. As you can see, I'm defining it as Ajax utils.sendGetRequest. And what we're going to do in this function is we're going to send a GET request to the server. So here's how this function is defined. There's the function right there. And I could see that I really need to put actually a semicolon at the end because this is just an expression, right? Expression of the function. Okay, so let's see what this function is expecting as parameters. Number one is expecting the request URL. Well, that makes sense. We need to know where to request, where to go to make that GET request on the server. So that's the URL. And we'll need a response handler function. So after the server responds, the response handler function is what is going to handle the result of what the server returns. Okay, so those are the two arguments we expect to be passed into this function. The first thing we're going to do is we're going to get that request object, and this is just that function we just spoke about, this request object right here. So we basically are going to get this new XML HTTP request object. So once we're done with that, once we get this request object, we're saving it in this local variable, and then we're setting this request object's onReadyStateChange to another function. So onReadyStateChange is the different stages in the network communication between the browser and the server. And we're going to see that in a minute. So what we're doing in this function is we're calling this handle response. And the handle response function is passed our request, this request object, and is passed the response handler as well. So when the server comes back with a response, this is the function that's going to get called. Every time there's a change in communication state, including the very final one that we're completely ready and here's your final response, this is the function that's going to get called. But we're not done setting up the request. The other thing we need to do is actually go ahead and make the open command with a GET request. So that's the type of request we want. That's the method of our request. We're going to pass it the URL, and we're going to make sure to say true here. And if you pass false here, it will make this request a synchronous request, which means the browser will freeze and wait for the response before doing anything else. And we don't want that. We want this request to be asynchronous. In other words, the second this request is made, we want the browser to continue operating. So in the last step here is actually to go ahead and send the request. So all of these lines right here were really just to set up the parameters of the request, what it's going to be like. And this line right here, the last line, is actually the one that executes the request and sends it to the server. The reason we're passing a null here is because if this were a post request, our parameters, request parameters, would not be part of the request URL, as you remember from the previous lecture, but it actually would be part of the body of the request. And this is where you put the body of the request. So if you wanted to have name value pairs for the request parameters, you would put that string right here, or probably save it in an object and then kind of paste that whole thing in here. Now let's take a look at our handle response function that we provided here. So the handle response function, as you can see, takes our original request object and the response handler function that our client, meaning our user, whoever is using this whole library, this whole Ajax util library, is providing for us. So we're kind of doing some kind of nitty-gritty work that they wouldn't have to do anymore. Number one is request.ready state. We want to make sure there's 4 states in this request.ready. And number one, we want to make sure we're in the last state. So it is ready to go. We don't have any other lower level network communications going on. And what they are is really not important, but what is important is that you have to check whether or not it's ready state 4. That's number one. And number two is we want to check that our request.status is 200. And this 200 is that response status code that we spoke about previously. So 200 means everything's fine, and here comes your response. And if those two conditions are true, only then should we then take the response handler, that is the function that the user of this library provided for us, and then we could go ahead and pass it the request that the user of this library will start pulling out of this request the response of the server. So that is how this response handler is being used. The last but not least is we want to expose this utility to the global object so we can actually use it. And what we're going to do is we're going to change the name of it a little bit. We'll say global dot, and we'll use the $ because we want to be all fancy, obviously. $ Ajax util. So just like jQuery uses $, we'll also use $ as part of our variable. So $ Ajax utils, that's what's going to be exposed to the global object, is going to be equal to our Ajax utils, that is the local objects right here in this IFI, in this immediately invoked function expression. Now, I hope you're wondering, at least a little bit, as to why this crazy setup is being made right here. On ready state change, we're passing it a function expression, so we're not executing this function, we're just passing the value of this function, not the return value, but just the value of the function object, and we're setting it to this property on ready state change. And inside of that, we calling handle response, and that is what is going to get executed, since you could see the parentheses around it. Why not simply erase this and happily call, well, we're not going to be able to fit in one line here, but happily call of this function right here. Why not have on ready state change equal to handle response? Well, first of all, we need to equal it to a function value, not the return of the function. So this would have to go away. You can't really pass parameters into a function value. Only when you're executing the function can you pass parameters into it. And we're not quite ready to execute this function. We just want its value. Well, if we did that, this function right here wouldn't really have the request or the response handler available. Well, one way we could take care of it, and unfortunately, and you'll see why I'm saying unfortunately, a lot of people do take care of it, is by doing this. We could just take this line out of here and make it a little bit more global. And now our request is available everywhere. So it doesn't have to be part of these parameters, part of these arguments. We could just pull it out of the global part outside of this function. And obviously we need to take care of this as well to make it valid syntax. So let's take a look as to what we've done. What will happen now? Let's say somebody on the page clicks some button that invokes this send get request. This will go ahead and use the request that already has been gotten right here, which seems pretty good. We'll assign handle response to our onReady state change. That's that function, and go ahead and make the request. The only thing is this handle response also really wants, at least in our case, wants the response handler function, and we're not passing that. But that's easily remedied by just saying var my handle response, or my handler, is equal to, and we will just equal it to this, right? So in order to do that, we could just say this is equal to null, and once we're done, we could just say my handler is equal to response handler. Okay, so now it's all complete. So at this point, this handle function, handle response, will be able to get the request and will also be able to get the response handler. So we really don't have to have these arguments to this function. The problem is that this whole thing is being called asynchronously. Remember what asynchronous means? It means that more than one thing could be executing at a time, which means once we send this request off and the server is waiting to respond, it could wait 2-3 seconds before it responds. Well, meanwhile, either the user or some other JavaScript process can call this again. And if it calls it again, it's going to end up using the same request object as we used for the previous request. And therefore, they will crisscross, get confused, and the response you're going to get is probably not the response that you were waiting for. And what you will have is what is called in computer science a race condition. In other words, there's some code that's going to be racing another piece of code, and whoever wins is going to override this with its data, but the second one will never be able to get to it or will give you the wrong data. So this is really going to be a gigantic mess. So let's go ahead and do a bunch of undos and put it back the way it was. So now we're ready to see how we're actually going to use this library in our script.js. And that's what we're going to do in part 3 of this lecture. So in the previous part of this lecture, we looked at ajaxutils.js, which is a small library we wrote in order to make Ajax requests to the server and process the response at least somewhat by being able to give our user, the user of our library that is, and in this case it's just us, the user of our library, to be able to give him the ability to give us a function that he'll be able to pass to us and will then get called when the server returns the response. So right now I'm located in script.js, which is located in lecture 57 folder. So let's go ahead and close the file explorer of Sublime Text and let's take a look at our script.js. Again, just as a very tiny review, ajaxutils.js is where we're defining our ajaxutils object to which we have one thing attached, which is send request. And again, send request is expecting a request URL, and it's also expecting a response handler function. So we're passing in a value of the function and a request URL. So let's go ahead and go to our script.js and see what we're doing here. The first thing we're doing is we're adding an event listener for DOM content loaded. So which means this only going to execute when the page has loaded all the HTML content but hasn't yet loaded all the CSS or pictures and so on. Well, we don't really have any pictures, so either way. And then what we're doing is if we take a look at our HTML, we have this button right here, and that's the only button in the entire HTML. What we're doing is we're unobtrusively attaching an event binding to that button. So we're doing document.querySelector and we're saying the button, and that's the only button in the document, so therefore that's the only one should get returned. And we're adding an event listener, we're adding a click event listener. So when the user clicks that button, we want this function right here to get executed. So let's say what we're doing here. Well, first of all, we're setting var self equals this, and we've seen this before. So, and I'm setting up a name. At this point, just going to be an empty string. And then I'm using our ajaxutils to call the server to get that name. So I'm saying ajaxutils, remember we set it to with a $sign. Let's take a look at it. We bound the $sign global $sign ajaxutils to our ajaxutil object. So the ajaxutils.send get request, and we're providing it the URL. So we're giving it the URL of /data/name.txt, and it wants a handler function. Remember the response handler function that takes a request object that's going to have in it our response from the server. Yeah, it's a little bit weird in JavaScript that the response object is still called the request, but it is, so we're just going to continue doing it. So the function is, again, we're defining it inline. We're not providing a function value, but it's an inline function expression. And we're saying that this name right here should be returned self.name. That's the name right here. And we want the request.response text. So request.response text, or the response text property of the request object, is what holds the response from the server. So we want to save that response straight inside self.name. Once we called the ajaxutils and sent this request, now that the name is set, we're doing a query selector on the content. And remember, the content in index.html is just this empty div placeholder. So we're calling this content, and we're using the ID of that content. And we're saying that inner HTML should be h2hello plus self.name, that's that name right here, plus the exclamation point. So it should say hello and Yakov Chaikin at the end. So let's go ahead and save that. And let's go to our page and open up our Chrome Developer Tools so we could see the console just in case. And let's go ahead and click this button and see what happens. Not quite what we expected, right? It says hello and there's nothing there. Well, let's verify that the server communication worked. Let's go ahead and print out the self. Let's do a console.log and let's print out self.name to make sure that self.name actually contains the words Yakov Chaikin. Let's save that. Let's go here and we'll say hello again. And as you can see, Yakov Chaikin is returned. So what's going on? Why isn't this outputting hello Yakov Chaikin? Can you tell what we did wrong? Well, what we did wrong was forget that this is an asynchronous call. So what's really going on is when we're executing this call right here, send request, it goes ahead and executes this call and it immediately returns and goes and executes the second line right here. Remember that visual from the previous lecture that I showed you? When the AJAX call gets made to the server, the very next JavaScript line gets immediately executed. It is not going to wait for the server to respond before it executes this next line. And that's because this call is asynchronous. So what do we do in this type of case? Well, what we do is we actually have to put all the functionality that is functionality that's based on the response from the server inside of our response handler. So we really have to take this whole line out of here, cut it out, and we'll go ahead and erase our console, and we'll put it right here. And that's the whole line is going to have to be right here. And in this case, we don't really need self anymore, do we? We don't really need to have kind of a global or outside of this lexical scope name. We can erase all this and we would just do var in here and say var name equals request.response text. And then when we're just doing a query selector, we don't even need self here either. In fact, let's see if it actually fits on the next line, and it does. So we're just saying hello, name, exclamation point. And that's really all that our function or response handler function is supposed to do. So let's go ahead and save that. And now when we go to our browser and click hello, we actually get hello Yakov Chaikin. And this string Yakov Chaikin is coming now from the server. So we made the full round circle from setting up the AJAX utils to making a call to it. And remembering that it is an asynchronous call, so if we're expecting something from it, we really can't do this after the call. We need to do everything to handle that response inside our callback function, which is what this handler callback was about. In this lecture, we're going to speak about processing JSON. And JSON is a format that is used pretty widely, especially when we speak about passing data between the server and the client. So what is JSON? Well, JSON stands for JavaScript Object Notation. And what it is, it's a lightweight data interchange format. And I'm taking this directly from json.org. And it is simple textual representation of data. It can't really get any simpler than this. And it's great for a couple of reasons. Number one is it's easy for humans to read and write JSON. And it's easy for machines to parse and generate JSON. So in a lot of sense, this is very similar to XML because it also was pretty easy to write for machines and for humans to read and write. But JSON notation is quite a bit simpler and shorter. And most importantly, it is, just like XML, completely independent of any language, any programming language. So what's the JSON syntax rules? Well, they're pretty simple. Number one is it's a subset of JavaScript objects literal syntax, but with a couple of exceptions. Number one is the property names must be included in double quotes, and the string values must be in double quotes as well. And that's it. There's really nothing else to it. The syntax for everything else is exactly like for object literal in JavaScript. Let's take a look at an example. So here I have an object literal, what looks like an object literal, but you could see that the property name is included, every single property name is inside double quotes. And any string values have double quotes around them as well. Not single quotes, but double quotes. All the other value, like false, like a number, are listed in the same way you would list them in an object literal. So this is the typical string that would really go over the wire from the server to the client. But even if you're in the browser and you're in your JavaScript program, you could certainly take the string and store it inside a variable. All you have to do is put single quotes around it. And the reason you put single quotes around it is because there are already double quotes inside of that string. So this is no different than any other string that you would have in JavaScript. Which brings me to a common misconception about JSON. JSON is not a JavaScript object literal. JSON is just a string. The syntax of JSON is based on object literal, but it is not one and the same. If you wanted an object in JavaScript, you would have to take the JSON string and convert it to an object. And similarly, if you want JSON, you would have to take an object and convert it back into a JSON string. And JavaScript provides a couple of utilities for that. Number one is if you wanted to convert from a JSON string into an object, you use this json.parse function. And backwards, if you wanted to convert from an object to a JSON string, you use json.stringify method. And yet, since we're in computer science, we're allowed to make up completely arbitrary English words. Stringify, there you go. Let's jump into the code editor and redo our previous example with JSON coming from the server instead of just a regular string. Okay, so we're looking at name.json file, and it is located in lecture 58 data folder, and we basically substituted the name.txt with this name.json. And this has what looks like a regular object literal, except we know it's just a string. It's a string that is sitting on the server, and you know it's a JSON since you could see all the property names are in quotation marks, and the strings are also in quotation marks, and they're both double quotes. So this is the same string we actually saw in the slides. Let's go ahead and go close the file browser and go to our ajaxutils.js. And what we're going to do is we're going to enhance them a little bit. When we say send date get request, we're going to provide one more argument called isJSONResponse. So we want to pre-process our response in ajaxutils.js instead of having to process json.parse every time inside of our custom scripts. So let's go ahead and do it once. So what we're doing here is we're saying isJSON, you're as a client of this code, you could pass it a true or false, or just omit it, and it will automatically, if you omit it, it'll automatically assume that you want JSON, but you could pass a false in here, and that will work as well. And our onReady state change property, which is going to go ahead inside our anonymous function, our closure, we're going to pass this isJSONResponse into the handleResponse function. Let's go ahead and take a look at this handleResponse function because it got updated a little bit. So now we are passing isJSONResponse. And after we figure out that it is time to handle our real response, we're going to first check whether or not we need to kind of default it to true. So if JSON isJSONResponse is actually equals undefined, then we want to set isJSONResponse to true. So if nobody passes us anything, we'll just default the response to be true. And then we check that if JSONResponse is true, then the response handler is going to be passed when we execute our response handler that the client of this code, in other words also us, but a different script.js is passing to us here. The response handler function, what we're going to pass to the response handler function is actually going to be already a parsed response. It's going to be response.text. We're going to parse it using JSON.parse. So what the response handler function is going to get as its argument when it is going to get called is a JSON, is a parse JSON string, which at that point will be an object. It's going to get a JavaScript object. And in the else, if they want actually not to have JSON be handled in this response handler, then we're just going to get them the actual response text, and they can handle it. Whoever is the caller of this can handle it however they want. Okay, so let's take a look at our script.js. Our script.js now has the same call as before, except this time what we're getting as part of our response handler is not any longer a request, it's actually the response JSON text that was converted into an object. So this res response is actually a JavaScript object. So we can now start building up our message. So here we're saying res.firstname plus res.lastname. So we're able to use it just like you would use any regular JavaScript object. And in fact, we remember that we had a property called likes Chinese food. If we take a look at name.json, likes Chinese food was equal to false. So we can actually use it inside of this statement like a true or false value, likes Chinese food, and it will properly resolve to false in this case because that's what JSON name that JSON returned. And message will be said does not like Chinese food. And the message will continue to be appended to, and finally we could say number of displays, and this is supposed to be a number, a real number. So if we wanted to say something else like +1, we can, but right now let's leave it alone. And when we do this here, we can finally say the final message, and then we'll select our content, which is our div placeholder in the index.html page. And we could go ahead and put that message in between the opening and closing h2 tags. So let's go ahead and do this. Let's save this, and let's go ahead and click say something. You can see it says Yakov Haikin does not like Chinese food and uses two displays for coding. So we could change that. We could go to JSON, name.json, and change that to true to see this in action. And we can even change this to say that displays is +1. So we're using it as regular primitives in both locations here, but we're using it through this RES response object that JSON.parse built for us. So if we save all that and go back and say something, it says Yakov Akim now likes Chinese food, which is definitely closer to truth, and uses 3 displays for coding because we added to the 2 that was responded to by the JSON and was converted into a number. We added a 1, so now it's 3. So to summarize, JSON is a lightweight data representation. It's a great format for passing data from the server to the client, and a lot of times back as well from the client to the server if you wanted to give it some more descriptive data. The syntax of JSON is based on JavaScript object literal, but please remember, JSON is not a JavaScript object literal, it's just a string. JSON.parse will let you convert from JSON string to object, and JSON.stringify will let you convert from the object to the JSON string. Okay, so now we're back to David Chu's China Bistro website again, and now that we're armed with JavaScript, we could do some really neat things with it. Number one is, let's go ahead and fix the issue that we left over for the JavaScript part that we couldn't fix before. And the issue was this: if we squeeze the browser and turn it when the button over here comes up, that the menu is a collapsed menu, and if I click on that, the menu comes up, but if I click anywhere here, I really expect that the menu should collapse by itself, but it doesn't. So what we need to do is we need to attach an event handler to this button that after we click it, the second the button loses focus, which means I will click right here somewhere. So in other words, in the JavaScript event handler speak, it's the blur on blur. On blur means that the particular element loses focus. Okay, so how do we achieve that? So first of all, we need to figure out when to do this, right? We obviously don't want to do anything similar to this on blur when we dealing with these big buttons. We only want to do this when it becomes this collapsible button. So if we actually turn on the Google Chrome developer tools, we'll be able to tell what the size is, and it's very clear that the button comes up around the 760, 68, 60, something like that, and that's a breakpoint obviously that we had and we've established before. So let's go back to our code editor, and right now I'm located in lecture 59 in the after folder. That's where I'm going to be working from, and the before folders again is a copy of the after folder the last time we left over the David Chu's website. In the state that we left it over, that's where this before folder is, the contents of the before folder are in. So what we need to do is we need to go to our script.js file, and I have some code here that I prepared for this particular lecture that we'll go over right now. Okay, so the first thing is we need to do something on blur. Well, I'm going to talk about this in just a second, but before we do, we really want this functionality to start when the DOM content is loaded. Well, the thing is that we would love to do just straightforward JavaScript, but we can't because we need to use the jQuery library, because the collapse menu was what we're trying to do here is a plugin that is hosted in bootstrap.js, bootstrap mean.js, and it's dependent on jQuery. So can't really avoid this jQuery library, at least for this particular piece. And even though this course doesn't really include jQuery library, you're certainly now equipped enough with JavaScript to understand what's going on. So let me go over in some detail as to what's going on here. The jQuery function name is actually $. That is exactly right. The name of the jQuery function is $. So what is happening here is there's a $, and then something is being executed, as you could see. The opening parens and the closing parens. So we're executing a $sign function against that. Well, what that does in jQuery, $sign function, is it's the same thing as the document.addEvent listener DOM content loaded, which means anything inside of this function that we provide in here, that's what that $sign function expects in this type of scenario, that if you put a function inside of it, what's going to happen is it's going to get loaded, or this function is going to get executed when HTML has been processed, but before all the images and extra resources have been loaded. So this is exactly basically the DOM content loaded event. So this is when this code is going to get executed. It's really as simple as that. So now let's take a look as to what's going on here. Yet again, we're reusing this $sign function. Well, the jQuery $sign function also has another functionality in that it serves as a query selector. So if we put something in quotes inside of the parens after the $sign, that becomes, or that serves as a selector. So really, this statement right here is no different than this statement right here that I wrote in the comments, which is document.querySelector, then #navbar toggle. So what we're doing is we're selecting an element with an ID navbar toggle. And if we go and look at our HTML, let's go and copy that and look at our index.html, and let's search for that. So this is our button right here, the navbar toggle, right? That's the button. So if that button loses focus, and as I told you, that means on blur, and on blur just means dot blur, which is exactly pretty much the same as we would do here. Once we would select it in regular JavaScript, we would say add event listener, and blur is the event. So this is what basically we're doing here. We're saying dot blur, when that happens, I want you to execute this function right here. And this function just says the following. I want to first grab the screen width, and as you see, we're doing window.innerWidth, which means it's the width of the browser window itself, not the entire screen of the monitor. And then if the screen width is less than 768, so we're basically checking if we're within that breakpoint where the collapsible button shows up. If that's true, right, and that button lost focus, what we want to do is we want to again select collapsible nav. Collapsible nav is that menu, and we could take a look at it right now. If we go to index.html and search for collapsible nav, and there it is. So this is the collapsible nav. So you can see this all our menu items right here. So point is, if we select that and we'll apply this function called collapse with the value of hide. Now this collapse function, and if you copy and we'll go to Bootstrap and we'll search for it in here, there's the collapse.js. So this whole thing is coming from inside Bootstrap, but it is a plugin to jQuery. So we can't really avoid jQuery, unfortunately, at least for this course. Or fortunately, I guess, you now learned a little bit something new. Okay, so now that we've collapsed it, we're good to go. And if we save that right now and go back to our browser, and now if we squeeze the browser to have the button show up, if we click on the button, the menu shows up, but if I click anywhere else, the blur event will fire and this whole menu should collapse. If I click, the menu collapses. Great. So now we're done with that little nugget and we're ready to move on to make the main part of our web page become much more dynamic. Okay, so in this lecture, we're ready to move on, and our next task is to load this entire content, this main content of the front page, to load this whole content dynamically. Now, first of all, why do we want to do that? The reason we want to do this is because we're trying to move towards what's called an SPA or SPA, and stands for Single Page Application, so Single Page Web Application. And besides for being a pretty popular web coding technique nowadays, since spas heavily rely on Ajax, this whole content right here is going to be inserted dynamically, but the rest of the content is going to stay. So we're going to basically update the least amount of the page possible to make it functional. And that's very advantageous because obviously it's going to be faster and also is not going to refresh the page for the user. It's going to be a much nicer user experience. So let's go ahead and go to our code editor, and right now we're located in lecture 60 in the after folder, and we're looking at index.html. Well, for that purpose, in order to make the entire content, the main content, dynamic, we actually need to wipe it out. And this is exactly what we did. We don't have anymore in the index.html the main content. There's only just a placeholder for the main content with the ID main content. Now, where did all of that stuff go? Well, we have a new folder here called snippets, and if we open that up, there is a file called home-snippet.html. So if we open that up, the entire contents of our home page are really contained right here. So you could see there's our Jumbotron, home tiles, and so on. We did change a couple of links. As you notice, the menu item here is no longer just a link, it's actually a link to basically nowhere with an on-click event handler. And we'll talk about that a little bit later, but we just kind of prepped it for the next step because obviously we're going to have to then display our menu categories page and then an individual single category page, and we're still going to have to do this using this SPA technique or using Ajax. That is, we'll need to take that content and dynamically insert it in the index.html right here at the placeholder main content. But for this lecture, all we need to do is figure out how to insert our previous main page content inside the main content placeholder. So let's go to our script.js where I've pre-written some code, and let's go over that. So first of all, you could see this code up top. This is what we just wrote in the previous lecture. This is just to make the collapsible button collapse the menu when it loses focus. Okay, so what we're going to do is, first of all, we're going to set up an immediately invoked function expression. As you can see here, we're starting with parents, global, and going all the way down here, we're executing this function, passing it the window object. So our global right here is really just the window object. And we're setting up a namespace DC, and just probably for David Choose. That's how I named it. And as you could see, we're exposing this thing right before the end of this whole function. We're saying global, which is really window, dot $DC. That's what we want to expose this as. And DC, our internal namespace. So whatever we attach to the DC as a property is going to get exposed to the global object in order for us to use it in some other page or some other script. Okay, so let's take a look as to what we're doing here. First of all, we're setting up our home HTML. That's nothing more than just a URL as to where that snippet is going to sit. And then we're going to have a convenience method here, so we don't have to write this from scratch every time because we're going to have to do this several times. Is if you give me a selector and you give me the HTML, I will go ahead and select that selector, take that argument, take that element, I should say, grab that element, the target element, and set its inner HTML to whatever the HTML string that you send me. So this is just a convenience method to say insert HTML, pass it a selector and the HTML string, and it will insert it into the target element. Another function that we need is show loading icon. It says show loading here. So obviously an Ajax request is going to be done asynchronously, and it will go out to the server and bring us back some content. But meanwhile, what is going to be displayed to the user? Well, we obviously don't want to display nothing. We don't want to display a blank. We'd rather display some sort of an animated icon that is going to show the user that something is going on. Well, Ajax loader.gif is an animated GIF, and I'm going to tell you in a minute where I got that from, but let me go over the code first. So show loading basically says, give me a selector to which I should attach this loading icon, and I'm going to set up a very simple div I'm going to put an image inside of that div and close the div. So this is just building up an HTML string, and it's pointing to this images ajax loader.gif. And then I'm reusing my insert HTML that I just defined and basically inserting that into this particular selector. So I'm able to then display this rotating or whatever it is ajax loader icon inside this selector that I pass in. Now, where did I get this index or ajax loader.gif? Let me go back to the browser for a second. There's a great website called ajaxload.info, and it allows you to basically choose different types of loading icons that you could choose and then set whatever background color you want and whatever foreground color you want and generate that icon for yourself, and there it is. And then you could click to download that GIF, and then you could use it on your website, and it's absolutely free. So it's a great website for these type of activities. But it's not the only one. There are others out there, and definitely Google for it, and you'll see some others that are, perhaps a little bit more creative, but not as straightforward. So let's go back to our code editor and keep going here. So we want to set up an on-page load. What we're doing here is we're waiting till the DOM content has been loaded. And in that case, once it is loaded, we're able to start executing things and basically executing queries, the selector queries that will actually find things, since we need the HTML to be loaded at that point in order to execute query selectors. And here what we're about to do is we're about to make that AJAX call that we've seen before. Well, before we make the AJAX call, we want to go ahead and turn on that show loading. And the show loading is going to insert in the main content ID, that element, is going to insert our rotating AJAX loader. So it's going to place it right here as the inner HTML of this element. Once it's done, it's going to issue our AJAX request. The AJAX request is going to be a fairly simple one. It's going to give us the home URL or the home HTML URL. And that's something we've defined right here previously. That's just the URL as to where that snippet is sitting. And since we're passing false as the last argument, as you remember, false means I don't want you to pre-process this as JSON, and we don't want this as JSON because all it is just an HTML snippet. What is going to come back in our handler function is just some text, actually just a response HTML. And once it does come back, we're going to select our element with ID main content and set its inner HTML to whatever the response text came back to be. And that's about it. So once we're done with this, we could save this, go to our browser, and switch to David Choose China Bistro through our browser sync. And if we actually reload this right now, it should very quickly get loaded, so the entire content is here. So let's actually take a look at the Chrome Developer Tools to make sure that what we think is going on is in fact going on. Let's go ahead and open it up and leave it on XHR, which stands for XML HTTP request. That's the AJAX request. So we don't want to see all the requests, we just want to see the AJAX request only. So let's go ahead and refresh the browser. And it's going to give us a whole bunch of requests here because we have Google Maps embedded in as well. So there's definitely lots of things going on here. But one of the things, as you see, is there's an AJAX request for home snippet.html. And that's exactly what we get. We get that little snippet over here. And that happens once the page loads and kicks off this whole AJAX process, which then goes ahead and fills in the content, the main content of our page. So if we take a look right now and try to click on this menu button right here, nothing's really going to happen. It's just going to sit right here. But if we open the Chrome Developer Tools and look at our console, we're going to see there's an error. The DC load menu categories is not a function. Well, that's true. It's not a function because we haven't defined it yet. That function is supposed to swap the content of our HTML page, the main content, to the menu categories content. And that's what we're going to do in the next lecture. In the previous lecture, we dynamically inserted the contents on the main page. So there they are right here, including the menu special and the map tiles. In this lecture, we would like to dynamically insert the menu categories when the user clicks on the menu tile. And actually, I already have this implemented, so let's take a look as to what happens. When I click on this button, I see that the menu categories come up with all the pictures and these things are also clickable. So very similar to before, except now we actually have all the pictures for the right categories as opposed to just placeholders. So these are dynamically being filled in. Obviously, at this point, we need the data to fill up these menu categories and also to point to these pictures that are specific to each category. So how do we do that? First of all, how do we get the data? Well, there's an app that we've deployed on herokuapp.com, and the app is called davids-restaurant.herokuapp.com/whatever. And basically what that is a REST API that provides us JSON data that we need for our application. And even though the actual website is going to be hosted on GitHub pages, so it's going to be GitHub pages.io or something like that, the data is actually going to sit as this app, as this restaurant, David's Restaurant app on Heroku. Now, this app is actually a Ruby on Rails app. And if you want to learn more about Ruby on Rails and how to create these apps all by yourself, I highly suggest you go to Coursera.org and find the Become a Rails Developer or Ruby on Rails Full Stack Web Application Specialization. And this is really this course right here that you're taking is actually part of that. So if you scroll down, you could see that you could get Ruby on Rails an introduction. You could go to the second course and then we'll dive a little bit deeper into Ruby and Action Pack. And you could get to MongoDB with Ruby on Rails. And this is actually a course that you're taking right now, HTML, CSS, and JavaScript for web developers, that is also part of this specialization. Even though you're not required to know any Ruby on Rails knowledge for this course, we're certainly going to use Ruby on Rails as our backend to get the data. So I would highly encourage you to enroll in this specialization. Now, the fact that this data is hosted on herokuapp.com and our application is hosted, well, locally right now for development purposes, it's being hosted on our browser sync, so it's kind of a local host, or eventually will get hosted on GitHub, the fact that they're hosted on two different domain names is actually a problem. And the reason that is a problem is because every browser comes with this security mechanism that's called same source or same origin rule. And basically what that means is if you load JavaScript that tries to reach out through AJAX to any other domain name other than the one that this particular HTML page was served from, the browser will stop that activity and will not allow it. And the reason it will stop that is because of the following. The browser and the JavaScript that runs in it runs as you, has the same privileges on your computer as you do. And if some remote script was allowed to reach out to other domain names other than the one you actually want to, what it could do, since you're operating behind a firewall and the JavaScript that's executing in the page is also executing behind a firewall because it is your computer after all, if the JavaScript was allowed to reach out to other domain names other than the one it was served from or the HTML page that you went to was served from, it could potentially reach out to internal websites and internal computers that it really shouldn't be able to even see. So therefore, what the browsers do is they enforce the same origin and same source rule. They don't allow that to happen. Now, in that case, how can we ever get this data? The browser is going to stop us. Well, comes this new technology called CORS, otherwise known as Cross-Origin Resource Sharing. And if you actually go, you could Google for it, CORS, Wikipedia page, and you could see this explained to you in some detail how this works. Basically, the idea of CORS is there's going to be some HTTP headers that the browser will know about and will tell the browser that it is actually safe to reach out to this particular domain name. And this is exactly what's going on in the case of this David's Restaurant app. It is actually communicating back to our browser and sending those HTTP headers, telling us that even though you really usually shouldn't be able to reach out with your JavaScript anywhere else, you're allowed to reach out to me and it is a safe thing to do. So that's point number one. That is how we're going to be able to get our data from our server that is going to be hosted somewhere other than Heroku or even just locally through browser sync to this Heroku app that is going to grab our data. That's point number one. Point number two is this is kind of hard to read what exactly this JSON is. So one quick trick you could do is you can open the Chrome Developer Tools, and if you go to the Network tab, you can even click All, and if you refresh this page right here, you will see that you will get this categories.json. That's the URL we're interested in. So if you click on that, you could go to the preview tab, and Chrome Developer Tools will be very happy to actually give you the preview of JSON in a very nicely formatted way, such that you could open up each data item and look inside. So you could see this categories.json is serving us JSON that is really an array of objects. So JSON is an array, this particular JSON string is an array of objects, and you can see here each object has an ID, has a name, short name, special instructions for this particular category. Okay, so now that we know where to get the data and how we're going to get the data, or how at least that's going to be possible, in part 2 of this lecture, we're going to go ahead and execute the code, the Ajax code, to pull this data, parse the data properly, and generate the dynamic HTML in order to insert it as our main content of our page. Okay, so in part 1 of this lecture, we spoke about CORS, the cross-origin resource sharing, and we spoke about where we're going to get the data. That is, we have a Heroku deployed app that is going to serve as JSON with the data that we need. In this lecture, we're going to go over the code that actually makes the Ajax request to that app, brings in the data as JSON, parses it, and populates an HTML snippet that is then able to be inserted inside of our index.html as the complete set of HTML tags that we need in order to display the menu categories page. The first thing we're going to do is look at a couple of snippets. So remember, we took out the menu categories.html and we actually substituted them with a couple of snippets. And I separated the menu categories page into 2 snippets. One is categories title snippet.html, and all it is just a heading of that particular page. Remember, the heading 2 is kind of the subheading already, and it's just going to say menu categories. And the reason I separated that is if you look at category snippet.html, it only has one category, or HTML for just one category. And the reason that is because as we get an array of these categories, we're going to loop over that array, and every time we get a category with this information, we're going to want to populate this little snippet and then make a copy of it and then insert it and keep building up our HTML. So this is what this snippet is about. This is really something that is more like a template. And if you look closely, I placed these what they call mustache, or these double curly braces that have properties that I'm going to want to insert into this HTML. And there are actually many libraries out there that do this very, very well. But since we don't want to introduce more and more libraries to this course, we're going to just stick to a very simple approach, as we're going to have a string, which is this HTML, and we're going to look for this particular string inside of it using the property names and substitute this property name with the actual value. So every time through the loop, we're going to grab these values and substitute these particular property name placeholders, if you will, into the HTML so we can get the real data. So you can see here what I'm doing is in every single menu category, I'm going to create this onClick event, and I'm going to call this DC David Choose load menu items. Well, we're not really going to write load menu items in this lecture yet, but we're going to prep it right now anyway. And what we need here is the short name of our particular category. And if you take a look at the data that we have here, let's open up this again and refresh so we could take a look at the actual data. So if you look at the data here, we have this short name for each category that is going to be very important, because we're going to use that to pull out other data from the app. So let's go back to the code editor, and basically that's what it is. It's really nothing more than that. And we have obviously several different properties here that are the same because they show up in different places of the same snippet. Let's go to script.js and see how we're accomplishing that. So first of all, we have some more URLs to deal with, and here I declare them here at the top. One is all categories URL. Well, that's the URL where you could get the JSON from our server-side app that will return all the categories that we have in our menu as a JSON string. And we have a couple of URLs that are just paths to our snippets. One is the categories title snippet, and the other one is the category single snippet.html. The insert HTML you've seen before, showing show loading you've seen before as well. One you haven't seen yet is insert property. Well, remember this snippet right here, category snippet.html. Somehow we're going to grab this as a string, right? We're going to grab that using AJAX request, and then we have this entire HTML as a string. Well, we need to then substitute every property that has these mustache or curly braces around, double curly braces around it. We need to substitute it with a value. Well, this is the function that's going to do it. It's called insert property, and I'm asking it for a string, the property name, and the property value. So this is the string where we're going to insert things into. The property name, property value, and is going to return, as a return value, is going to return the string already with those property values inserted instead of the property names there. So the way we're going to do this is we're going to set up, first of all, the property name. Remember those curly braces. And what we're going to do is we're going to use a replace function of the string class and use a regular expression object, except we're not really going to use any kind of a fancy regular expression. It's just going to be the property to replace that property that we've set up. So just the verbatim string that we've set up, we want that replaced. And the only reason we're using this regular expression is because we want to specify this flag G, which just tells us go ahead and replace it everywhere you find in this string right here. So not just the first place you find, but everywhere you find. So since we have, for example, in this category snippet, we have this name property showing up quite a few places here, we don't want it to replace just the first one it finds, we want to replace all of them. And here's the property value with which you should replace that particular string. Once we're done with that, we return the string and we're good to go. So this is how we're going to take the string, the snippet, and we're going to populate it with property values. Okay, so scrolling on down, we have the AJAX send request. That is for the main content that we've seen before. And here's our load menu categories function that is going to get triggered in order to pull all these categories into the page. So the way we're doing it is, again, we're first going to show our loading icon. And usually on these sites, the server is going to be fast enough that you're probably not even going to notice that loading icon kind of flashing and going away. But if the sites get a little slower or the data comes back a little slower, you will eventually see it. And we're making our AJAX request afterwards, and we're using our all categories URL. That's the URL to our Heroku app. And we're passing build and show categories HTML. That is a value of a function that is defined actually right here. And since we don't really need the true right here, it is default, which is going to go ahead and leave it off, which means that this function right here will get categories, we'll get whatever that is the first argument in the function is. It's going to be an object that is converted from the JSON string. So it's going to be a full-blown object. So once this AJAX call is done and this function is called, we end up here. But we're not done with AJAX just yet, right? First, we need to go ahead and request the categories title HTML. That is that snippet of HTML that just gets the category. And we need that string in order to append it to the rest of it. So once we get that string, we really are not ready to do much with it yet. We need to make yet another AJAX request, and notice that that AJAX request is sitting inside of this one because it only makes sense to make the second one when the first one is actually over and we are in the context such that we could grab the result of the first one. So there it is. So technically speaking, this would be the third AJAX request we're making. And we're making that request to get the category HTML. And that's that snippet, category snippet.html. And once we're done, we have all three pieces of data that we need. We have the categories object that lists all the categories. We have the title of the page, the snippet of the title of the page as a string. And we have a single category HTML snippet that we can now use. So all we need to do now is maybe call some function like build categories view HTML. So now we're actually building the view, pass it the categories object, pass it our title snippet, and pass it our actual category snippet. And we're going to go ahead and build that view, store it inside a variable, and once we're done with that, and that is a synchronous call, there's nothing asynchronous about this, it's just synchronous call, we're going to use our insert HTML to place it inside the element with ID main content, and there's that string that we're placing inside of it. And notice both AJAX calls, this one and this one, both pass false because we don't want the AJAX utility to try to process our snippet, our HTML snippets, as JSON. So let's go ahead and take a look at this build categories view HTML. Well, it's a pretty simple function. It goes ahead and builds up our final HTML snippet by grabbing the categories first. Remember, we need to put that whole thing into a row. So remember, that section piece is not really here anymore because it only comes once, and there's a whole bunch of these that are supposed to happen. So that is what's happening here. We're inserting a section with a class row, and then we're looping over our categories object. And every time we pull out the name, the short name, and all we're doing then is just insert property. Remember that insert property function we discussed? Well, this is where it's coming very handy. We insert property, and every place where there's a name property inside our snippet, it gets replaced with the value name. Same for short name. Finally, we're done, and we're looping over this every single time. And notice that every time we're copying the category HTML, that's that snippet that has the properties in it, into HTML, which means we're separating. Remember the pass by value, pass by reference? Well, this is copy by value, which means this is a copy that is not connected to this anymore. So every time through the loop, we get a new copy of it right here, and then we can insert the new values to it once again. And once we're done, we just return our final HTML that's built up. We close the section tag, and then it goes back right here, what we spoke about before, and that just inserts that inside our main content. And that's how we get to this place right here, where when we go to the front page and click on this menu, it executes a function that pulls in all of this right here into our page. So now we're done with the many categories page, and it's time to move on to a single category page. So when a user clicks on a soup category or appetizers category, they should be able to see all the menu items for that particular category. And that's what we're going to code up next. In the previous lecture, we populated our menu categories page dynamically from the server, pulling the data for our menu categories page from the Heroku app that is implemented in Ruby on Rails. In this lecture, we're going to do something very similar, but this time we're going to pull the specific category and all the menu items for that specific category. Right now I'm looking at category snippet.html, which is located in lecture 62 folder in the after folder. And the reason I'm looking at the category snippet.html, which is something we implemented in the previous lecture, is because I want to take a closer look at the hook that we used in order to get, or at least set up, in order to get to the point where we could click on a single category and get the single category menu items. Well, the hook is right here. It's on click, and we're saying DC or $DC load menu items, and we're putting in this short name right here. Well, load menu items is something we're going to look at in a minute, but the short name is very important is because that seems to be, at least, the property which we use to get at the data for a particular category. Let's go back to our browser and go to our David's Restaurant app and see that there's another REST API endpoint, as they're called, that says menu items JSON. That's what we want, and we're passing it a request parameter called category. And depending on what this letters are, this letter or letters, we're going to get different results. So for example, if we do VG and actually refresh that and click on that, and let's take a look. So here, VG, it gives us an object, or gives us a string, a JSON string that will be converted to an object that has two properties in it, category and menu items. Category is yet another object, and menu items is an array of objects. So if we open that up, we could see all these objects that are inside that menu items array. They're really just menu items for the category that was returned, and the category is returned as a property called category. Now, depending on what we place here, let's place here L, for example, for lunch, and if we scroll back up here, we'll see that now we're in the lunch category, and here are all the items for the lunch category. So point is that short name is pretty important for us because that is what we're going to use to append to this base URL right here. This is going to be our base URL, and we're going to append this, whatever that they click on, we're going to append that letter or number of letters like VG to be able to get at the particular data for that particular category. Let's close up this extra window right here. Let's go back to our code editor And let's take a look, let's close this snippet and take a look at the couple of snippets that we're going to use for this. Number one is menu items title HTML. And since I have this implemented already, let's actually take a look at the end result. So if we're in the front page and we click on our menu item here, or menu tile, we get to our menu categories page, and if we click on, let's say, lunch, we'll get to our specific menu category, which is lunch menu. And you can see that we have a whole bunch of menus here, a whole bunch of menu items with pictures, and we have two components here, which is what I divided over there into snippets. One is the component of the actual heading of it, so which says lunch menu and gives some sort of specific instructions for that category, special instructions. And then we have a separate one that just lists every menu item in that category. So let's go ahead and take a look. Here is the menu items title. You can see here we're going to say whatever the menu name is, menu, like lunch menu or vegetable menu or something like that. And we're going to list the special instructions right under that. And both are basically bound to this particular thing with these curly braces, double curly braces, mustache, whatever you want to call them. But from the previous lecture, we already know how easy it is for us to insert our property values instead of these property names, so that's enough said about that. Let's go to our script.js and take a look as to how we're accomplishing this. Okay, so we have a few more URLs to deal with. Number one is we have the menu item URL, menu items URL, and as you can see, is the URL is the same URL we use, except category equals doesn't have anything equal to. Well, that's because we're going to append the short name of the category on the fly. And then there's the two snippets, the menu items title HTML and the menu item HTML. So if we scroll down, these are all the functions we've seen before, and we get to this one that's called load menu items. And it looks very, very similar to the one before. It's basically almost the same, except that when we make the AJAX request, we are taking the menu items URL, we're appending the short name that was passed to us through the HTML snippet. Remember the HTML snippet, the category snippet, when it said dc.load menu items and it passed us the short name right here? Well, this is the one that we're looking at right now. That got closed for a second. Let me scroll back to that function. Load menu categories right here. Load menu items. So this is the category short. That's what got passed into us when the user clicked on that particular item. So our URL that we're making an AJAX request is now complete when we put those two together. And we're also designating again a function that is going to process the results of that AJAX request. And again, it's going to be JSON, so we don't need to put false in here. We're actually going to default to JSON processing. So build and show menu items HTML. Let's go and take a look at that function, which is right here at the bottom of those two. And basically, we know that category menu items is going to be an object that's going to get returned because our JSON is going to get processed. And again, we have these double AJAX requests, very similar. First, we're getting the menu items title HTML, that's that snippet. Then we're going to get the menu item HTML, that's the single one. If we take a look at here, menu item HTML, it's quite involved, but this is exactly what we basically pulled out of our single category, that HTML page. And all it is just basically placing those properties in the proper places in order to construct, for example, a URL that we need for the JPEG that is going to be sitting inside the images folder. We have the prices here and price small portion name. Sometimes the price is small, but sometimes there's only one price. So we're going to have to deal with the fact that sometimes we're not going to have a small portion name, which is going to have one price and no other price here, and the name and the description of a particular item. So in terms of formatting, really there's nothing for us to do because we already done all the formatting through Bootstrap in the previous lectures. Okay, so if we go back to our script.html or script.js, all we're doing here is very similar construct as we're building up our menu items view HTML. And again, we're passing that object category menu items, passing the HTML snippet for the title, and passing the HTML snippet for the one single menu item. Once that gets built up and saved into menu items view HTML, all we have to do is insert it into an element with an ID main content, and we're done. And again, false here because both of those AJAX requests don't need to process these snippets as JSON, they need to process them as just a regular string. Let's take a look at this build menu items view HTML. Unlike the previously similar function, we actually need to insert some values inside of our title as well. So in this case, it's going to be name and special instructions. And the name and special instructions come from category menu items. That's that object that was returned for us from the Heroku app as our JSON that was converted into an object. Dot category, that's our property. Dot name. And the same thing here, menu items, category special instructions. So once we insert that, our menu items title HTML is actually ready to be used for our final HTML. So that's why we're starting this final HTML with this particular variable that's already kind of pre-inserted with the values of our object. And we're again starting the section as a row. This is something we stripped out of that particular snippet because, again, this is only one of these lines, and that snippet is going to get repeated over and over and over again for every single item in the menu category. So once we're done with that, we are looping over the categories. We're looping over the menu items. Well, it says as your categories, really it's menu items. There we go, this first mistake right here. Okay, so we're looping all of the menu items, and we pull out the short name because we're going to need that for constructing our URLs in order to get to our images. Because if you look at our images, our menu items are inside the menu, and then every single one has a letter that's the folder for a particular menu category, and inside that folder we have this A1, A2, A3, and so on. That actually needs to be constructed using the short name of the category, not necessarily just of the menu item. Okay, so that's basically a bunch of inserts that is going on here. And the only difference here is that we have a separate function for insert item price and insert item portion name. And the reason we do that, let's take a look at insert item price, is because not every time do we have a price. For example, a price for a smaller portion might not even exist. So we first check whether that thing even exists. And if it doesn't exist, what we insert instead of that, obviously we can't just leave that curly brace, small portion price value or property inside our snippet. We don't want that showing up to the user. So what we're doing is we're inserting the property named price prop name, which in this case I think is something like either small price or large price, and we're substituting it with an empty string. So basically just wiping it out so nothing is in that particular snippet with that value if that value doesn't actually exist. And what we're doing next is we're actually, if it actually exists, we're going to go ahead and use toFixed2, which basically means we're going to not have $3 or something like that. We're going to have $3.00. And so we're formatting our price to be a proper dollar amount. And then we're using our insert property as before in order to put that in. So that's in the case that it actually exists, that price value actually exists. If not, we'll insert an empty string. And the rest of the HTML is very, very similar. We keep inserting the values. The portion name is the same thing. Sometimes portion doesn't exist in that type of particular value, so a large portion may not exist, or a small portion name might not exist. So that's why we need to send it through a special function, and all this code is available so you could take a look at your leisure a little bit slower, the way I'm kind of flying through this a little bit. But I want to give you the concepts of it, not necessarily go line by line. There's one more thing we need to do. Remember the clear fix, right? We can't control how large these menu descriptions are going to be. Some might be too large, some might be too short, and we don't want our grid to be messed up. So what we need to do is after every second menu item, after every second menu, or after every second grid cell, we need to place this clear fix HTML. And that's what we're doing here. We're using actually the remainder function or the remainder operator in JavaScript. So we're saying I remainder of 2, division of 2, and we're saying that if that's not equal to 0, meaning there is a remainder, so we have item 0, we have item 1, item 2, item 3, and so on. Well, item 0 is our first item, right? Because it's a 0, arrays are 0 based. Item 0 is our first item. Item 1 is our second item. And it's after the second item that we need to place our clear fix HTML. Well, that means that every odd number, and this is basically what we're saying, that every odd number index is what we need to append this clear fix HTML to. And if it is, we do, and we move on and finally produce our final HTML. And that final HTML, just like before, gets inserted into our main content, gets saved into this menu items view HTML, and gets inserted into our main content. And that's how we get, when we get to our page and click on here and click one of these items, we get our single category items page. In the previous lecture, we pretty much completed our David Choose China Bistro website, except for one small thing. And let me demonstrate that by going to the command line. I'm actually going to go into the before folder of lecture 63, which is our current lecture, and I'm going to go ahead and start the browser sync just to let us see what was before we started and implemented a change. Let's go back to the code editor or the browser, and let's refresh the page here. Okay, so when we go to the menu categories page and click on it, there's something missing. This menu right here, this menu button, should be highlighted just like that, but it's not. And the reason it's not is because obviously it's not a separate page, so the active class that used to be on here that used to light this up like that is not there. So what we need to do is unchange when this happens, when the menu categories page gets loaded, and for that matter, when the particular single category view gets loaded, we need this button to be in the active state. Let's go back to our code editor and see how we implemented that. We created this function called switch menu to active. And what we're doing in it is the following. First of all, we want to remove the active class from our nav home button. Remember, if we go to our browser and actually squeeze it, what's going to happen is that even though you don't see it, but actually it's sitting on the home button. And if we go to, right now we actually are already on the particular menu category page, this really should be on the menu button, not on the home button. Okay, so let's go back to the code editor. So what we need to do first is we need to remove that active class from the home button. And the way we're doing it is we're selecting an element with an ID nav home button. And actually, if we select that and go to our index.html, and try to find that, it's right here. It's that menu item right here in the top right of our site, unless of course it's squeezed and now it's in the collapsed menu. But it's possible that the nav home button has the active at the moment, and actually that is the default when we load up the page, is that the nav home button, which is hidden on the desktop browser display, is the active one. So we need to remove this active class from the list of classes of here, and we need to insert it into the menu button instead. So let's go back to our script.js, and we need to scroll down a little bit again. And so switch menu to active. Okay, so the first thing is we're getting the class name, and the class name is not one class name, it's really just the class attribute. And the class attribute can have many classes. In our case, in HTML here, you could see that it has visible XS and active. So there's a couple of classes that could be in there separated by spaces. And the way we're doing this is we're using that same replace function of the string class to say we're going to create a new regular expression. And again, it's not going to be a very fancy regular expression. It's going to be just an expression that looks for a literal string active. And the only reason we're using it again is instead of just saying, right here in the first argument is active, the string active, is because we want to use this flag G, which lets us say that anywhere you find this, so if there's more than one for some reason in there, they will all get replaced with the empty string. So we removed the active class from our element that has an ID nav home button. And the result of that, we're going to save in this classes variable. And then we're going to turn around and override the class names or the class name attribute value for that nav home button to the classes, but these classes are now, or the string is now without the active class. And the second thing we're doing is we need to add the active class to the menu button if it's not already there. So the first thing, we're going to go ahead and grab what are the class names that are inside this nav menu button and check if the index of active, this word active, is -1, and this function index of returns -1 if it cannot find the string inside the string that you're applying this method on. And if that's the case, we're going to go ahead and add classes equals classes plus active. This is what this plus equals, as you remember, means. And obviously, we want to make sure to give it a space because there might be a class there already. So we'll put a space in here. And then we're again selecting, using our query selector, the nav menu button, and having that class name or the class name attribute equal to the classes that we just constructed, which is whatever classes were there before, plus the active button. Okay, let's see if that actually works. Let's go back to our command line and switch our browser sync to being from before to after. And let's go ahead and fire up our browser sync. Let's go to the browser. And we could just close this and just simply refresh this. And here's our browser sync. And now if I go to, let's say, menu, right here on home is selected. If I go to menu, and I see here that now menu stays highlighted. So if I actually open this up, I could see that the menu button is highlighted. And if I go to a particular menu item or particular menu category with all the items in it, menu is still highlighted. So if I go back to home and go back to menu and go to a particular menu category, I could see that the menu button stays highlighted. Okay, other than maybe putting up some information in the About section and the Award section, our website is 100% done and ready to be deployed. You've made it. You've completed the course. Congratulations and thank you for sticking with me through this journey. I hope you enjoyed it and learned a ton. So where do you go from here? If I may suggest the next course in this specialization, which is single-page web applications with AngularJS. Angular, which is backed by Google, is one of the most popular front-end frameworks today, and there's a reason for that. You can accomplish so much functionality with so little code. So check out the course and enroll. The entire Johns Hopkins team worked very hard to produce this course and deliver it to you in the best way possible. So if you like the course, I'd like to ask you to take a few minutes of your time and give this course a 5-star rating. It would mean a lot to us. Finally, keep in touch. Follow me on Twitter, connect on LinkedIn, and join a special Facebook page we created just for the front-end courses of this specialization. The links to all of these things are below this video. Thank you for watching, and all the best to you.